I hope I'm audible to the participants. A very good morning and welcome back to this 1 week online short-term training program sponsored by AICTE on water quality complication, restoration and environmental conservation of existing water bodies, Module 2. We are on the day 5 and we have with us Dr. Ratish Menon, sir. He is an associate professor in the Department of Civil Engineering of SCMS, School of Engineering and Technology, Cochin. He has been an exchange faculty in the University of Ravensburg, which is in Germany. He has also been a visiting researcher in Department of Energy, Environment and Chemical Engineering, which was at Washington University, USA. He has been a project engineer at Indian Institute of Technology, Bombay. And during that tenure, he invented the first ever database of air pollution source profiles in India. He is from the MES College of Engineering, Kerala, an expert in environmental monitoring, modeling and data analytics, also policy development. He is a doctorate from the Indian Institute of Technology, Bombay, and was actively involved in the development of water policy for Kochi and providing technical support to various government and non-governmental organizations. Sir, I welcome you on behalf of the Civil Engineering Department of IPS Academy, Institute of Engineering and Sciences, Indore. We are highly privileged and honored to have you with us today. I thank you that you could take out time from your busy schedule and enlighten us over this particular issue of water restoration. Thank you so much, sir. And I request you to please take over the session, sir.
Thank you, Dr. Devanshi. So I can share my screen here.
Yes, sir.
Can you see the screen?
Yes, sir.
Okay. So thank you so much for inviting me to this AICTE STTP. I understand that today is the final day and this is the first session. So this the theme here is, as I understand, it's water quality and how do we restore and conserve the existing water bodies. So the topic that I want to discuss today is about an emerging issue, mostly focused on. It's a global issue, by the way, and it's an emerging issue, and it's an effect due to the urbanization happening in a tremendous pace. So in India, it's going to be a severe problem, and this is regarding the microplastics. So plastic as a pollutant, we all know the impact of plastic, and that's why the government has brought up policies and regulations banning some type of plastic, not all, but some certain type with certain thicknesses they have banned. But still the problem persists because of legacy waste, and these plastics always find their way into the water body. Microplastics, what are they, and how do we sample and how do we characterize this? I'm audible, right?
So the voice is a bit breaking.
Is it? Yes. Let me switch off my video here. Right. Is it now?
Yes, sir, it's now clear.
Yeah, yeah. Okay. So what I want to cover in is about microplastics. How do we sample it? How do we characterize this microplastic? And what are the impacts of microplastics on our environment? So according to United Nations, by 2050, it's a very pessimistic, I would say, pessimistic prediction that the oceans could contain more plastic than fish. And to some extent, it could be true because the way in which we are contributing plastics into the ocean, this is a possibility by 2050. So, along with all other issues of climate variations, we have to deal with this particular menace. And this is very evident if you look at the Pacific Ocean. There is a particular garbage patch. Many of you may be aware that it's about millions of kilometers accumulation of fragmented plastic. It looks like an island from space, actually. This garbage patch is between United States and Japan, and this plastic accumulated at this particular spot because of the ocean circulation. So actually, the plastics entered into the water bodies, and they have finally ended up in ocean. And due to the ocean currents, they have accumulated in a particular way to form this Pacific garbage patch. So if you look at the photograph of that, you can see the intensity or the extent of this kind of accumulation that is happening over ocean. Now imagine what could be the impact of that on the ecosystem and also on the animals, aquatic animals, and also on the ocean evaporation. So these are big types of plastic waste that is coming in. Now these wastes can also get fragmented into tiny pieces, and that is when we get the problem of microplastics. So if you look at the story of a plastic bottle, the plastic bottle, if you throw it into the environment, uh, in the land, if it is buried in the soil, it is impacted by various parameters. For example, UV light, then the temperature variations, then aberrations, which can actually fragment it into tiny pieces. And that is true even when it is thrown into the river due to the action of salinity and the UV. All these things can be fragmented into tiny pieces. And this fragmentation continues, and these pieces get smaller and smaller. As it becomes smaller and smaller, the control or the treatment becomes very challenging. So if we look around, we will see these microplastics everywhere. So it's actually a necessary evil, so as to say, because we can't live without it. But addressing it, then it is also a part of our economy, and that becomes a problem when it ends into when after the usage. That's a problem. When we need it, we use it, and after the usage, we never bother about what is its fate in environment. So we have different micro beads, we have different items, glitters, cosmetics, all of them contains these microplastics. So if we look at the size categories of so-called category of microplastics, it starts from anything lesser than 25 millimeter, and it can go up to nanometer scale. So based on the size range, we can classify these microplastics into macro, which are bigger plastic fragments. Then meso, when its size is less than 25 millimeter or greater than 5 millimeter range. These plastics are visible, and we can collect it and remove it from the environment. Then comes the micro plastics, which is less than 5 millimeter in size. Then it becomes a problem because collection of these microplastics is not so easy. Then there is another classification of microplastics, which are called mini microplastics, which is less than 1 millimeter and goes up to 1 micrometer. So 1 micrometer size is not that visible to our naked eye, and it can also end up in whatever we eat, whatever we drink, and whatever we inhale. So microplastics is also a problem in air. So it can also be we can inhale microplastics. We can drink, because if the microplastics are coming into the water, then we will ingest it, and it can also be part of our food chain. Because if you are eating fish, there are many studies showing that the fish contains microplastics in their tissues. So what I want to say here is that as the size reduces, the plastic size reduces, uh, its pathways in environment multiplies. It can move in various ways in environment, and also its removal becomes very challenging. It's not possible to remove at all. So we may need certain policies to prevent its entry into environment. So we will discuss about that in this session. Now, if you look at the microplastics pathways, uh, it comes from many anthropogenic activities. It can come from domestic sewage through the usage of cosmetics or tissues or plastic covers, the domestic garbages being dumped on the land, which will again end up into water bodies through the erosion and the soil erosion and the flooding. And it can also be coming from industries or agricultural activities. In agricultural, mulching sheets are a big problem. They put sheets of plastics over the agricultural area to prevent evaporative loss. But these mulching sheets then becomes part of the soil, and then it ends up ultimately into the water bodies. Then it can also be directly thrown into the water bodies in the form of fishing gear or what nets, fishing nets, or cargo losses. All these things can carry into these microplastics into environment. What I have shown here is the pathways into the water. Similarly, the pathways are there, which becomes part of the food chain, and also it can also be re-entrained into atmospheric air, and we may inhale it, and it goes into your lungs. So that's about the different pathways in environment. Now, this is an interesting study in which they have taken the data from 1971 to 2013. These are all the data collected from the surface trawls. So when the ships move on our ocean, they use a plankton net or something to collect the microplastics from the surface, and those are counted or weighed in a gravimetric analysis is done. So here, this graph, this chart shows the numbers of microplastics found per kilometer square of area. So we can see that these samplings are mostly confined to the United States and its surrounding. Uh, Not so much of data is available in this part of the world, that is near to our Indian Ocean. So we don't know yet what is the scale of impact on our oceans. So here we can see that there's a huge quantity of microplastics are present all over the ocean. Now, what do we do with this? That's a very challenging problem. Now, if you look at the microplastics fragmentation, so microplastics can come from primary sources like industrial materials or personal care products or cleaning products that we use at home. It has microbeads in it sometimes to increase the abrasion and therefore improve the cleansing process. And then we can have secondary microplastics coming in from the macroscopic plastics fragmentation. So like a plastic bottle thrown into the environment, that fragments in the environment and becomes part of microplastics. Now, these microplastics can remove these processes is coloration. If plastic was colored, it had environment. This color discoloration can happen. Morphological changes, especially for polystyrene or thermocol, these changes, and its size reduces uh, through more fragmentation or disintegration. Then it can also have crystallinity changes, is microplastic. And another impact is that these microplastics, when they are in environment, uh, bacteria can grow their a biofilm around these microplastics. So this was observed in many water bodies here in Cochin, where we have microplastics combined with microbial films, especially when it is coming from solid waste dumping grounds and all. They have biofilm growth, which increases actually its density. So problem with increase in density is that when the biofilm grows over the plastics, uh, it becomes heavier. So normally the microplastic should float because the density is low. But when it is combined with this kind of biofilms, the density changes and it settles down. So when it is in water in a suspended form, it is quite easier to remove it using a net or something. But when it becomes part of the sediment, then the problem is quite complicated. So this biofilm growth over the microplastics increases the density, and therefore it will settles and become part of the sediment. So that's a problem actually. Now we look at the classification of microplastics. So we now so far discussed about what microplastics and how do they end up in environment and what are the various ways in which they can move in environment. Now let us try to classify these microplastics, not in terms of size, that will be already discussed, but in terms of three different properties. One is the origin, and the other one is the shape or form, and the third one, the most important one, is the polymer type. Now, based on the origin, we can classify the microplastics as primary and secondary, whether it is directly coming from application or they are actually converted or formed in the environment. That is what we mean by secondary. They are not coming in microplastic form from the source. They are coming in the macro form, but then in the environment under different weather conditions and environmental parameters, they disintegrate and become part of microplastics. Now, the second category is based on their shape. So these plastics can be of various shapes. They can be either fibers, they can be films, fragments, pellets, beads, many different shapes. So these are only a partial list of the shapes. There are all kinds of shapes, and there are shapeless also. Then polymer type. Polymer type, there are n number of plastic compounds that are in use in the world right as of now. We can identify at least 25 different kinds. But this is a major kind of polymers that we observe in microplastics. They are polyethylene, polypropylene, polystyrene, polyethylene terephthalate, which is called Dept. So all these things are there, and this is how we classify based on polymer type. So we look more into the details of this classification based on origin. So primary, as I mentioned, they are originally produced in the micro size. So why do we need micro size plastic in a product? It is mostly in cosmetics, textiles, and other applications. So these are the primary. Secondary, as I mentioned, they are toothpaste, you can see some beads, micro beads are there in some of the brands. Then shower gel, you see tiny micro beads are there in the shower gel to improve the cleansing action. All these things are, and face wash that you may be using, you will see these micro beads. Now when you wash it, the micro beads are there and it ends up in your wastewater, and these micro beads ultimately end up into the environment. So those are called primary. Then secondary, they can come from various kinds of materials like clothing, plastic products, uh, different items of plastics. So they result in the breakdown. They result from the breakdown of larger plastics. So that is why they are called secondary, because they are not directly emitted as microplastic. They are emitted as macroplastic and they come into environment, and under the weather elements they disintegrate and become part of microplastic. So that was the classification of microplastics based on the origin. Now we already discussed about different shapes. I'm just showing you some images here so as to relate to that shape. So the fibers, you see there are like threads, or these are normally coming from the fishing nets or from disintegrated clothings, uh, synthetic rayons, all these things can come, or from bristles or from brushes. These are called fibers. They are linear elements. Then there are pellets of various sizes. Then films. These are the fragments normally coming from different kinds of bags or carrying bags, etc. Then fragments, form is normally, if you see the thermocol, you can see that there are these forms. Uh, these forms can disintegrate and you can get these kind of shapes. Then microbeads I already mentioned, microbeads coming from the cosmetics. And one of the interesting microbead is something called glitter. We use a lot in India, especially during the festivals. We use glitters uh, write certain letters or to decorate. So these glitters, you must have seen these glitters in the market, and these are also used in makeups, cosmetic products. These glitters are a big problem. They are very tiny and they have a lot of surface energy and high adherence capacity. They are used widely in India, mm, and they cannot recycle. They have sharp edges, so they attach to anything. You must have experienced it. If you touch the glitter, it will be all over your skin. So it has that kind of adherence capacity. Now imagine what will happen if it ends up in the water body, and it attached to the surfaces of aquatic organisms, and that puts them under pressure, or that can actually kill them also. So this one, this glitter is a big menace in India, and we see a lot of it in the water body. And they are dangerous not only because they are microplastic, but also because of these colors that you see, the attractive colors. These are all heavy metals. So all these heavy metals, in combination with the plastic, they becomes like a torpedo to the aquatic animals. So this is an overlooked pollutant, and we have no policy or no regulations on the usage of these glitters. Yeah. So coming over to the polymer types, as I mentioned, there are various types of polymers that are in use. Some of them are shown here. Polystyrene form, you may identify it from the thermocol sheets that you get when you buy a new fridge or TV. Then polystyrene, polystyrene. It's not in a foam manner, but if you remember, you get these disposable plates made up of polystyrene, and they are thrown into the environment or garbage dumping stations. They fragment and become part of the microplastic. Then polypropylene, the disposable glasses that you use. Then LDP, low density polyethylene, coming from plastic bags, covers, or toys, like that. So there are various types of polymers, and their impacts and their pathways are different. Their impacts are different because of their shape. They can impact the aquatic organism in different manner. Some of them can be ingested. Some of them get attached to their skin. Some of them obstruct their mobility. So all different kinds of stresses can be induced based on the types of the shape and types of the polymer. And the different polymers have different origins. So controlling these is a very big challenge. Now, understanding the this importance of the microplastics, uh, people have started studying it. As of in 2018, there was a paper which analyzed the literature of on microplastics. So we see the different types of microplastics. Mostly studied microplastic is polyethylene. Then comes polystyrene, and so on. And polypropylene is also there. And the big impact is being studied on fishes, but lesser studies are there on small crustaceans and other organisms. Now, you can't separate out one species from the ecology, right? Everything are connected. So there is what we see is there is a wide range of impacts on different species, including animals, birds, reptiles. So various kinds of species have different impacts, but mostly we studied so far on the impact on fishes. So that indicates a necessity to explore or do more research on what are the impacts on other different kinds of organisms uh, present in and now. So if we come to the studies from India, uh, so this one is from Kerala, and we have the second largest uh, Ramsar wetland here. It's called Vambanad Lake. It's a backwater. And from there, this particular study has taken several samples of sediments, and they could find that 250, around 250 particles per meter square uh, is the microplastic content in these backwater sediments. And these mainly consist of polyethylene, polystyrene, and polypropylene. So these are the three important polymers that we find in our backwaters. And of course, they come through the rivers that are flowing through the urbanized areas. So ultimately, they end up and get dislodged in the backwaters. And because this backwater is being dependent by a lot of people for their livelihood, it becomes an issue. Now, if you look into the north, if you there is a paper from River Ganga, which actually showed that the range is 100 to 400 particles or items of microplastic per kilogram of the sediment. And there they have mainly found PET, that is polyethylene terephthalate, and polyethylene. So major portion of their fragments are PET and polyethylene. So that's a study from River Ganges. And if you see, a lot of studies are there internationally, but in India it's limited. So that's shows also the importance of this particular topic in when we deal with the water quality and river restorations. Yeah, and yeah, so This is from Kochi. This is a river in Ernakulam, and this is a study we conducted, and we found that 2% of microplastics are there in the river sediment. Per 100 gram of sediment we collected, around 2% of the sediments are containing microplastics. So this particular sampler that we used is called Van Veen Grab sampler. This is a good sampler for collecting sediment. So we insert it into the river bottom, and then we close it and pull it. So we get the sediments, and once we have the sediments, we can do a lot of different analysis on this sample. Now, how do we characterize microplastics? So is there a particular protocol? So far, there have been only one major protocol internationally accepted. This is called NOAA protocol. NOAA is an organization, as you may be knowing, National Oceanographic and Atmospheric Administration under US government. They have developed a protocol because this Pacific garbage patch became a huge problem for US. They have been studying the issues of microplastics for a long time. So they came up with a protocol. This National Oceanographic and Atmospheric Administration came up with a protocol for how do we collect, how do we sample, and how do we characterize these microplastics. So the protocol is mentioned here is basically for sediments, but the same is applicable for aqueous phase microplastics also. Aqueous phase means suspended in water. So from the bed sediments, we do we wash it with the potassium metaphosphate to disintegrate the bed sediments so that the microplastic will be freed, and then they are sieved through sieves of different sizes, and then their size range separation is done using density separation. Then before we characterize or before we do any microplastics, we do wet peroxide oxidation. So wet peroxide oxidation protocol is for removing organic mass from, if there are, as I told you, the biofilms can form, or organic matter can be attached to these microplastics, especially glitter and all, which has high surface area. They get attached to many things. So we want to remove all those unwanted things, and we want to see only the microplastic and what is their size, what is their type, etc. So we wash it with a oxidizing agent, which is called hydrogen peroxide, and this is called WPO method, wet oxidized. And then after that, do the density separation. Then finally going for microscopic examination and gravimetric analysis. So this protocol is widely being used in the world. There are many modifications that people have done as part of their research, but ultimately the base protocol is the NOVA protocol. I know this shows the characterization path. So once then the then after that we do the density separation, then finally go for filtration. So ultimately we have to filter out the plastic fragments. Then these extracted microplastics are taken to FTIR spectroscopy to identify the kind of polymers that make up these microplastics. So the quantification, so FTIR is done to identify the polymer, but the quantification of microplastics is still done manually or under a microscope, because we have to count the number. Most of the time, weighing it is not a good idea, because if they are very small in size, you may need a lot of microplastic samples to have sufficient enough mass of microplastic. So usually they are represented in terms of numbers per either the area of a river or numbers per the sediment mass, like that. So the quantification is generally done through the manual counting under a microscope, and we have come up in our research institute, we have come up with a technique to use computer-based algorithm and artificial intelligence-based algorithm to count this effectively. So I will mention about that algorithm later in this session. Now, finding the polymer type, we can use Raman spectroscopy or FTIR. Right here. Yeah. So Raman spectroscopy is looking at the scattered light, but FTIR is looking at the absorption light. So basically, Raman spectroscopy is a little bit high cost technique. FTIR may be cheaper, inexpensive technique, and they are both effective in identifying polymers. But the issue is they are they are destructive in nature. They cannot characterize the microplastic as a bulk. So what we do is we have to give individual pieces of microplastic. We have to identify and select it manually, and then we take that to the spectroscope and analyze for what kind of polymer it has. That's a issue in characterization. Another technique here is when we want to look at the shape, morphology, and their surface characteristics, we go for scanning electron microscope. And if you want to identify the polymer other than FTIR, there is also one more technique. It's called differential scanning calorimetry. So differential scanning calorimetry is not dependent on the light scattering or absorption, but it looks at the thermal variation, the property changes of the this sample with respect to temperature. So we look at we increase the temperature as a how this sample behaves under different temperatures. So different polymers have different ways or different behavior under different temperature. So from that property, we can actually identify what kind of polymer it is. So that is the principle of differential scanning calorimetry, or we call DSC. So Raman spectroscopy, FTIR, DSC, SEM, all these are useful to characterize microplastics. Now, these are all they all analyze the microplastic that we sampled, we processed, and we submitted for the analysis. But sometimes real-time measurements may be important to make right decisions of control. So these are not real-time measurement devices. They are done at lab. We collect the sample, do the processing, and then do the analysis in the laboratory. But there have been a development in real-time monitoring of microplastics. So that is using ultrasound scanning. So that's quite a promising way of looking at microplastic pollution. So first sensor have been deployed recently in 2018. This uses ultrasound scanning, And so the image comes like this. What we have found, we see here, the blue patches shows the organic mass or sediments, and the red spots that you see are the microplastics. So we can in real time, we can actually look at how much is the concentration of microplastics, where are they, and how do they behave. All these things can be done. But of course, it's real time and it's expensive. So this is a real time technique. I just wanted to share with you this information. So we so far we discussed about what microplastic is, how do we classify the microplastics, how do we sample, what are the protocols for sampling microplastics, how do we characterize the microplastics. Now we talk about what are their impacts. So mostly when I say impacts, I am going to talk more about the aquatic organisms, because uh, water or water bodies are the main uh, collectors of microplastics from the urbanized areas. And these water bodies all have life, or various different species thrive in these waters. Some are very small size species like copypods. These are free swimming species. These are all food to fishes also. So anything happening to these kind of organisms, tiny organisms, can also affect the food chain and thereby impacting the ecology of that place. So we have copypods, bivalves. Bivalves are shells. They are filter feeders, so as to say. They take in water and food along with the water, and then filter out the water to get food. So these bivalves have a problem when you have a lot of microplastics in the water. They remains inside, and when it accumulates a lot, then the species dies. And also fishes that eat on these tiny organisms like copypods or other organisms that I will show in next slide, they end up in their guts or their tissues. And if very small microplastics are there in the tissues of fishes, ultimately when we eat the fish, it ends up in our gut. So this continues. So the impact on the ecology or the ecosystem is tremendous. This is just aquatic food pyramid. You all know this. It starts from the phytoplankton to up to bigger fishes in the water. And this particular microplastics, they travel vertically in this aquatic food pyramid through something called bioaccumulation. So when it impacts any of that at the bottom, primary producers, if they impact primary producer or first order consumers, then the entire pyramid can collapse. Now, this is a particular organism which we find in most of the freshwater ecosystem in India. It's called Cyclosteria islopi, and this is a crustacean species. Is benthic. Benthic means they are mostly found at the bottom of our water body, and they are actually proteinaceous food for fishes. So wherever you have fishes, the mainly you will find these species. These, because these are the primary food for the fishes in rivers or lakes, and they are filter feeders, so they are very much under risk of microplastics. So this is one of the organisms that we are studying as of now. And how do we collect these organisms? We collect it using plankton nets, and these nets are taken, and in boats you can roll it in the water body, and you can collect these organisms, as well as we get microplastics, and then we collect them to experiment with the species or dissect the species and try to understand how much has been ingested, how much microplastics are there already in these organisms in the field, or we can actually culture it in the lab and do a lab study on what are the impacts of microplastics on these organisms. So that's what we do. So this is the Cyclosteria slopy. You see the nice image here. So you can see my mouse. This is the antenna here, and these are this intestine, this linear element here. These are the brood pouches where they lay eggs. These are they are moving. They are benthic and as well as they move a lot. So these are their legs here. Now, in one of the studies, it was reported in Nature, people have used another organism called Daphnia. Daphnia is a free swimming organism, aquatic organism, and it is also for fishes. So what they have done in the study is they took fluorescent polystyrene particles, okay? Fluorescent polystyrene particles, very small size particles, nano size particles, and try to see what happens when this organism is introduced into microplastic environment. So this was originally the image A is the original organism before exposed. It's a we kept it as control, and this exposure you see how much because these particles are fluorescent, you can get a good view under the microscope. So you see that these organisms actually ingested these polystyrene particles. They have even gone into their brood chamber. Brood chamber is where they have embryos. Okay, so even it went into these embryos. So not only the species dies, its eggs also neutralize, and that actually can cause ripples in the ecological pyramid, right? Food pyramid. So when the particle size becomes smaller and smaller, uh, it impacts these very small organisms in aquatic in water bodies, and whenever they die out, fishes starve, or fishes may feed on these organisms before they die, and then this will ultimately end up in the fishes and ultimately ending up onto humans. So now microplastics itself is not the only threat. Microplastics can be combined with so many other pollutants. For example, pesticides or heavy metals, and these can uh, increase the toxicity on the species when it gets attached to it. As I mentioned earlier, the problem of litters, because of high surface area, they have high adhesiveness, so they get attached to the skin of the species, and or they get ingested and bioaccumulate. And because it has associated pollutants in it, like pesticides or heavy metals, they become more toxic and they can kill the species. So microplastics are a pollutant, but not only that, they're also carriers of pollutants. So that's like a big problem, right? So if you have a pollutant which can also carry several other pollutants, then their impact becomes uh, greater. So in a recent study from Kerala, again in these backwaters, they collected different species of fishes, and 32 out of 123 fishes, so approximately 26% of fishes they examined had microplastics in their gut. Okay, so that means that's a real and present danger here. And I'm sure if you analyze in other water bodies in India, you will find uh, these kind of results. And the problem is that these plastics are going to stay there for a while. They are not going to go away, and it's very difficult to rejuvenate these water bodies without addressing this particular issue, because we do not have a mechanism to clean up the sediments or these legacy plastics that are already there. Plastic ban is wonderful, it is okay, but what about already existing these fragments of microplastics? That is something we need to think about. Now, a scary result was published from Italy in 2021. It's something called pre-polluted babies are becoming a new normal. Now, what is pre-polluted babies? You find microplastics even in the placenta of a babies. That shows the importance of addressing this particular issue. So it's not only on those tiny organisms that I showed you in earlier slides. The issue is not only that, it is actually moving vertically in the food chain, and there is trophic level accumulation that is happening. And they also get attached to the body fat. And also, as I mentioned, these microplastics are carriers of several chemicals, and there is a high chance of chemical poisoning also. And this pre-polluted babies are a beginning of the problem and need a thorough study on. And this has happened in Italy. Okay, so you can imagine what will happen in India, because European countries are more stringent on these things than India. So we haven't studied it fully in India, so we don't have any data points from this country, and I'm sure that this won't be an isolated case in Italy. Now, to share my experience from the work that we are carrying out in Cochin. Going to that, I would like to. Do you need a break, or Dr. Devanshi?
Sir, if you need a break, we'll take it for
Do we
2 minutes.
continue, or
So as you feel comfortable, sir.
no? I am perfect. I am okay. I I am okay. If participants needs a break, then we can break.
So we can continue, sir. It's very interesting.
That no problem. Yeah, yeah. So so far, what I have been discussing was about the fundamentals of microplastics, how they are formed, what are their characterization techniques, what are their impacts on different species. Now, let us look at one of the results from our studies that happened in Cochin. It's already ongoing study, and I'm sure it will continue for several more years because there are a lot of unanswered questions here. So this study is being conducted in a urban in a river. It's not a big river; it's a stream, we can say, but it passes through the urban area, and it has only a total length of 27 kilometers. So you understand, it's a very small stream, so as to say, and it has a catchment area of 115 kilometers square. The interesting fact is that this stream, even though it is small, it flows through all major industrial, economic, residential zones, and a lot of sources are there uh, for pollution. There are a lot of chances for pollution, and also this river itself is a source of water for surrounding area. So a lot of people are dependent on this for getting water. A lot of industries depend on it to take water, and also they contribute to the pollution. And a part of it is also an ecotourism destination, unpolluted part, so as to say. And there is a big dumping site near downstream, and where we collect all the solid waste coming from Kochi city. It's just a dumping yard. It's not a sanitary landfill. It's a big dumping yard. And now they are bringing up controls on this unscientific dumping, but there are legacy waste there. And when they have a big dumping yard near to a river, you can expect that there will be leaching and runoff. All these things can come into this river. So this is that solid waste dumping yard I mentioned. It's located at the bank of this river, just being dumped. So you see that there are a lot of waste for east here, and it has only gone up because of the increased urbanization that is happening in Cochin. Then every day they receive uh, at least 72 tons, but it is more than that. We conducted a waste audit there. It was 150 tons there. And the leachate, the treatment plants are not working properly. They have these leachates joining the runoff during the monsoon season and joining this water. So there are a lot of opportunity for these plastics. You see from the image itself, you can see a lot of plastics are there, and they have been there for a while.
So we cannot hear your voice, sir.
And they
So probably there was some network issue.
hello.
Yes, sir. So there was some network issue. We
I will
lost your
share it again.
voice,
Just
sir. Yes, sir.
okay, okay. Is it fine now?
Yes, sir. Now we can hear you.
Oh, okay. Just a second. So where was I? Did you hear this part? This slide?
So please share your screen. Yes, sir.
Just
Now. Yes, sir. We just reached the slide and the voice went off.
okay. Sorry for that.
No problem, sir.
Okay. So this is the dumping yard near the river of our study, and you can see a lot of plastics are there being dumped. It has been there for a while, and there's a lot of opportunity for the formation of micro fragments of these plastics, which again finds into this way into the river during the monsoon season when there is a lot of runoff that is happening, and the leachate also carries into the river during the monsoon season. Now, this is the location again. A lot of scenic places along the stretch of this river, and we have been moving around taking samples from there. So these are the main industries or institutions and along this particular river. So we have info park development happening, smart city projects. Then there are a lot of industries and some institutions also. So all of them depend on this river. So it becomes very important. One, in terms of its quality. Second, in terms of its conservation. It becomes very important to conserve this stream because it's a lifeline of so many people. So our objective was to identify if this river, so-called river, how polluted it is in terms of microplastics. So instead of these water samples, we focused on sediments because we found that we took the water samples, so we couldn't find much microplastics in the water. But when we took the samples, we took the topsoils, we could identify fragments of plastic. So it had to be in the river, right? So we could find it in the topsoil. So the question was, oh, why it is not in the water? But then these topsoil microplastics had a lot of biofilms on it, a lot of organic waste. So it was like a matrix. So we thought that this will be settling because, as I mentioned earlier, it can vary the density of these plastics and it can settle out. So we collected samples also from the sediments, and we collected it from 7 places along the stretch of this river. And we did it in the post monsoon because during the monsoon the river is flowing full, and also there are a lot of turbulence which can stir up these sediments. So we wanted to see when the sediments are not when they are in undisturbed state. We collected the samples, and we use the sampler we mentioned in earlier slides, and then we do the sample oven dried, and then we sieved it. And in civil engineering lab, we can have various kinds of sieves. Then we did the wet peroxide oxidation as per the NOVA protocol, the density separation using sodium chloride, filtration, then finally did the microscopic evaluation before sending out for the further characterization in terms of the types of the polymers. So when under microscopic examination, we could find that there are a lot of fragments there. So in the sediments, what we found is that about 0.6% by weight, microplastics are present. So it's not the percentage by weight that is important. It is what important is the numbers of these fragments. So it's a sufficient number is the 153 numbers. When the mass is small means they are tiny fragments. They don't have much mass, but they are huge in numbers. Okay, so these microplastics were found um, all places, but mostly in the downstream of this particular solid waste dumping yard. So this was expected actually because we were expecting the runoffs to bring in the small fragments of microplastics into the river, but it was downstream, but there were also microplastics in the upstreams. Okay, so that means it's not only the sediment, this dumping yard is not only the source of it. And in the topsoil, you can find, we found the microplastics everywhere. Okay, so that means it's not so particular only for the dumping yard. Of course, dumping yard contributes to microplastic, but there is also contribution from urbanized areas. and they have higher numbers of microplastics in the topsoil than we found in the sediments. So ultimately, this topsoil is what eroding and bringing in this microplastic into the water body. Now, earlier when I mentioned about counting, it was very difficult to count it manually. When you count it under a microscope, there are chances of errors, and it's not a very faster method, and it's not very easy. So we developed our own method using deep learning algorithm. What we did was we took the images of the pictures, and using the image processing and the deep learning algorithm, we counted this particle automatically. So all we need to do is to submit an image of the filter into the algorithm. The algorithm will process and give you the size distribution of particles in that filter. So that makes our job easier. So we get an output like this. So the size distribution and the diameter, area diameter of the particle. Okay. So we have run several, we did a lot of training of this algorithm because this is based on artificial intelligence. We have to train this algorithm with a lot of known filter images with the known particle sizes. Then later, when we have an unknown filter with the particles on it, it can correctly identify and give us the size distribution of microplastics. So that made our job easier. Now using that, we analyzed all the samples, and we came up with the size distribution of the microplastics in topsoil as well as in the sediments. Okay. So the light blue color is the topsoil one, and the dark blue is the sediment. So of course, the quantity of the microplastics, as I mentioned earlier, was more in topsoil compared to sediments. Uh, that is expected because topsoil is more in connection with the human activities, and the sediment gets it only during the monsoon season. And there is also chance that during the monsoon season, the sediments that are deposited over a year are stirred and taken into Arabic Sea. That may be a reason. We haven't concluded it yet. We are trying to analyze why that is so. Now here the size distribution, if you see, we see that the particles are more in terms of, if you look at the size, larger size. Okay, these are all in millimeters. So in sediment, most of the particles are larger in size, but there are smaller particles also present. 4.75 to 2.36 millimeter size ranges are the dominant size range in the topsoil as well as in the sediments. Then we took it for FTIR analysis as well as DSE analysis, differential scanning colorimetry, to identify what kind of polymers are there. Interestingly, we found that polyethylene consists of 55%. Now, polyethylene originates from plastic bags, food covers, etc. Now, food cover is an interesting finding. Like people, after there are a lot of urbanized, it's an urbanized area, a lot of people settle there, and there are a lot of food movement in covers, these polyethylene covers. There are legacy waste also in the dumping yard. People also order food in online. These covers are thrown out, and this polyethylene, it becomes a major part of the microplastics, at least for this particular river. It may be different for different rivers and different states. So if we look at for in urban water bodies in indoor, maybe it's very different. You may find something else as dominating. But at least here we could identify certain major polymers. Polyethylene was one, then polypropylene is there, then polystyrene was also there, PET is very small, PVC is also small. So this kind of source characterization is possible. So we identify the microplastic, we collect samples, we categorize it in terms of its size as well as in terms of its composition. So this information is very much needed before bringing in any rule or any kind of ban. Okay, so if you just ban the same thing for the entire country, it may not work sometime. We always call it as plastic ban, but what we have banned so far is only a part of polyethylene, only some kind of covers that use under 50 microns or 75 microns, like that. So we need to identify for each state, maybe, or for each region, we have to see what kind of plastics they are getting, what kind of microplastic we are finding, what are the different sources, and then devise some strategies to control that particular source. Otherwise, we will be like, um, we will lose our vision. We cannot clean up our water bodies. We can only clean up our water bodies if we identify the root cause and try to prevent. Once it is there in the ecosystem, or once it is there out there in the environment, then it is a big problem to control all this. So for us, in this particular river, polyethylene was identified the major contributor to microplastics. So now we need to identify what are the activities that contribute to polyethylene, and what are the regions that are contributing to this river, then devise some policies or controlling strategies to avoid polyethylene coming into these sediments. Now, whatever is there already, we have no other choice but find some ways to clean it up, but it is not an easy task. But at least we can prevent it from coming into this river in future. Then under the microscope, we have seen a lot of different kinds of shapes, sizes. So fibers and fragments. So fibers, some of them are from the ropes or the fishing nets. The fishermen, after fishing, if the net breaks down, they have a tendency to throw it into the water. These fishing nets, thrown out fishing nets, remains there, degrades, fragment, and contribute to tiny fragments of fiber. So we talked about the impact of microplastics on small organisms. Now we wanted to check it. What are the different ways in which it impacts these kind of organisms? So we did come up with the laboratory scale study. For that, what we took is we took these glitters. These are polystyrene particles, and they are small in size. And these glitters, when we introduced these organisms into these glitters, after some time, what happened is that these glitters get adhered into the surface of these organisms. They get attached to this organism. Now, what will happen to the organism? The organism cannot move. Their mobility reduces. So initially they are very mobile, but after some time their movement gets restricted. So what we observed is that these glitters attached to the organism, they are filter feeders, so they need to suck in water and food, and the water is filtered out. So this filter feeder mechanism is blocked, and they are immobilized, causing stress and disturbance and some. So we studied the mobility. We kept the organisms. We selected similar kind of organisms and kept it under the microscope and studied for a longer time, 48 hours of observation. So we had a control, that is the bottom part, the chart here you see, and there is a after introduction of the microplastics, how it changes. So these particles initially they move randomly here and there, but after 48 hours they come up and their movement is restricted. They cluster around, so that means their mobility is affected. But we found an interesting observation here for this particular organism, that once they got a lot of these particles attached onto the skin, this particle molt. Molt means they change their skin. So molting is done molting is a normal procedure for these organisms, just like snakes molt. They remove their skin and they refresh their skin, right? So similarly, these organisms also molt. Molting is an aging process for this species, but uh, an induced molting was observed because of the uh, because when they come in contact with the microplastics get attached to their skin and it irritates that species, and then it molt, which is not natural molting, it's an induced molting. That was a very interesting observation, which is now being communicated in a paper. Coming out to this summary of this work, of course, we identified microplastics. It was there, the problem is right there. We identified the type of microplastics also, and we now know how to automate the counting, and yeah, the 50% of the polymer is polyethylene. Now we are continuing our studies here, and ultimately what we want to know is the pathways of these microplastics into the sediments, and also how these microplastics are impacting the food chain. So we now know the impact on one of the small species. Now how it impacts the food chain, that will be closely monitored. And also we are studying how these microplastics are becoming carriers of heavy metals and other pollutants. As I mentioned, that this can also be a carrier of many other pollutants. So we are also analyzing this microplastic for the presence of heavy metals and other pesticide and all. So ultimately, what we want to say is that to calculate the environment risk, we need to understand not only the sources, abundance, or fate, or exposure, so as to say, we also need to understand the hazard due to the microplastics. The hazard can come from various sorbed chemicals on these microplastics, and hazard and exposure together causes the risk, right? So a risk assessment is to be done, and policies have to be formulated to control at least the entry of these microplastics into the environment, or else this will be the most important problem that we will be facing in the coming years, because all our food or water, because all our conventional water treatment plants, they never look for these kind of new age pollutants. We have micropollutants, we have microplastics, nobody bothers about that in the conventional water treatment scheme. We only go for rapid sand filtration, or activated carbon filtration, all these things, but they are not enough to remove these kind of new age pollutants. So unless and until we update or we extend our treatment system, this will end up into the public distribution network. So these are the things that we need to understand. And also rejuvenating these water bodies is a big issue. Already plastics are there in the sediments and all. How do we remove these plastics? Now, there are many ways in which people look at this problem. They have devised certain ways to coagulate and remove it from the water. But finally, what we do with this, how do we dispose? Even though we separate out the microplastics, now what we do with this plastic? So the pollution once created can never be destroyed. It can only be converted from one form to another, right? So we can remove the pollutants from the water, it becomes solid waste. And if you burn it, it becomes air pollution. So So ultimately, there will be some impact that needs to be understood. So thank you very much. I think I gave you a brief overview on this particular aspect and particular pollutant that we have to expect in future. So I would be ready to take any questions if you have. I think we are on time here.
Thank you, sir, for this very interesting and wonderful aspect of microplastics that needs to be addressed right now because these are the emerging pollutants and we don't know how to exactly degrade them. So that was a very interesting aspect that you touched on. And if any of the participants have any questions, they can unmute themselves or even type in the chat box. I request the participants to please raise questions if they have. Well, sir's presentation was such elaborate and very clear and precise that I don't think there was any questions raised because I was so mesmerized by the way and the work which we are doing. It was very evident and clear, the protocols, the methods, you already specified everything.
Yeah, you can write to me if you have any, if you are continuing, anybody is continuing in this area, you can always write to me and I will be happy to help. Because we have done only in Kerala, and I would be interested to look at all other parts of India, how it looks. Yeah.
So definitely we hope to get in collaboration with
Yeah.
something in future.
Okay.
Thank you so much, sir,
Yeah.
on behalf
Thank
of
you.
the Civil Engineering Department at IPS Academy. And I hope to see you in person sometime in future, sir.
Sure. Thank you so
Thank you
much.
so much, sir.
Thank you. Bye. Bye.
So that was a wonderful talk on microplastics by Ratish Menon, sir. Now we will be moving towards the next session that is scheduled at 12 and we have an international speaker from Qatar. So I request all the participants to be there so that we can have an international view of this particular agendas. So hope to see you again in say 5 minutes or so. So I welcome all the participants to this 1 week online short-term training program on water quality complication, restoration and environmental conservation of existing water bodies, Module 2. We are privileged and honored to have with us Dr. Manoj Chaturvedi sir today. He is a chartered environmentalist, MIEMA, GSAS and CGP at the Metito, Doha, Qatar. He is working as an environment and sustainability manager. He has more than 25 years of cross-functional experience in handling multidisciplinary projects in the mainstream and allied areas of industrial environmental management and sustainability of built environment in India, Qatar and UAE. He has managed several projects funded by the international agencies that includes European Union, World Bank and SIDA, as well as state and central government agencies of India. He has also assisted ministries of urban development, environments and forests of Government of India in execution of JNNURM projects in city of Nasik on behalf of GTZ ASEM as environmental consultant. He has authored more than 30 technical papers and several technical reports. He has also worked as a guest faculty at Indian Institute of Technology, Bombay, to teach industrial wastewater management, reuse, and environmental management for master's and doctoral students. I thank you, sir, on behalf of IPS Academy, Institute of Engineering and Sciences, Indore, and very much thankful that you could take out time from your busy schedule and enlighten us, especially that you accepted our invitation and request, sir. Thank you so much, sir, and I request you to please start with the session, sir.
Thank you, Dr. Devanshi, for the introduction. I'll just share with my slides. Is the slide visible to all?
Yes, sir. It's visible, sir.
First of all, I apologize for the delay. I got caught in another meeting and it got extended. Therefore, I could not come in time. So I apologize to all the audiences. And
No problem, sir.
nice. Okay. I will not take too much time of you, but would like you to if you have any question, you can write it down, and at the end in the discussion we can talk on that thing. So today I'm going to discuss about the water, as you just said that water related quality and criteria and other thing that is part of this CEP program. So I would like to discuss about those things, and especially my emphasis will be on natural treatment system, how it could be utilized. So before that, I mean, although majority of you already know, but just to give a pretext, I just wanted to give you, with all development, all funding and investment that we have made in India, the government of India has done it, still we are far behind in terms of the treatment of the sewage, okay, which is being generated by our community. This is the one scenario. This is CPCB data, so it's true also. But at the same time, we cannot say. I mean, we have been projecting this that we don't treat this much and we directly put in natural water courses. It doesn't happen. In India, there are two kind of treatment systems are there. One is that is conveyed and it is going through treatment unit, and second is the on. So on-site treatment options like septic tanks and others, they are not accounted. However, in calculation, they make it. Okay, so that is how also scenario gets changed. So it is not that everywhere, I mean, we are putting in our rivers and natural water courses the huge amount of water that we see over here. But at the same time, this is true that it is also not the case that in all receiving water bodies we are getting clean water from different nalla and other things. So there is a problem and there is a solution. So we will have to, I mean, come in between. We are a developing country, so our solution should be in line with what we can afford, not only to install through the central funding, but also to the operate. So major challenges that we have, the gap that you just saw or what I just discussed is the installation and operating cost of existing technology for wastewater treatment are rather high and hence are ill affordable by the communities. To bridge this gap, central government and state government provide to municipalities some initial capital investment, the capital thing that they provide. But the major problem happens when it becomes operational cost if they are not able to manage by bringing the money from the community who are utilizing the services. The availability, they are often complex, they require heavy machinery, capital intensive, energy intensive. Since they are complex, they need a specialist for the operations, and in some of the remote areas, specifically class 3 town, class 4 town, these kinds of skills are not available. Even if it is available, they are not, they do not want to visit those areas. So most of the time, post installation, systems are either working not at per as they are designed, or they become dysfunctional after some time. Large volume of continuous discharge network water courses, just I said. So what is the solutions? We have to look at appropriate system, and natural treatment systems comes in that way. They are low cost with minimum possible mechanization. They are simple in operation. They are suitable for incremental improvement. They are recycle and reuse oriented. Compatible quality of treated wastewater. Even this court cases and other things that have come, the Green Tribunal NGT has also come up with the requirement that 10 BOD at the outlet. That cannot be achieved by our conventional system, and even by enhancing its efficiency, if we are able to bring down the energy cost to operate, will be too high. So for a conventional activities-led process or even MBR and MBBR, we can bring down to the 30, and post 30 we can use natural treatment systems for various operation. In some cases, if the inlet BOD is less, say 100 or 150, that case natural treatment system can directly be put on use post certain pre-treatments. So there are four groups of natural treatment systems which are typically being utilized. It's not new. There is nothing new in the natural treatment system. It has been used in India, and it is being used since ages. I mean, in 1970, Professor Soliji Archiwala, he was third or fourth director of NIRI. He compiled one document on waste stabilization pond. And that time also there were 120 wasteland ponds working across India with different capacity. When even I was doing PhD in year 2000 to 2007, that time also I had assessed natural treatment system working in different parts of the country, and I have found in almost all states there were operational and dysfunctional treatment system. In Kolkata is the best example for, effective application of natural treatment systems. Other cities are also adopting in different. So there you might have heard East Kolkata wetland. East Kolkata wetland is nothing but a natural treatment system based on the aquaculture pond system followed by aquaculture. So that also does. So there are four, like I said, that first is WSP, waste stabilization pond. That is the basic natural treatment systems that is being utilized with some modification. And in typically WSP, you have first, anaerobic pond to bring down, uh, remove recalcitrant compound and other things in the anaerobic systems. Then you have facultative pond, and finally, maturation pond or polishing pond and its outlets. In Miraj and Karad in Maharashtra are, if you see, uh, different suburban areas of Kolkata, majority of installation ponds are being utilized. Then we have constructed wetland. Constructed wetland, most of you might have heard it is being now even coming in the tender documentation that constructed wetland treatment system should be applied and other things. So in constructed wetlands, the base system work like you have a settling unit followed by, plant area that is also called on the basis of initial plant that we utilize reed bed. So, and then you have outlet. But some people feel that just having this system will work effectively. This is not the case. You have to have some pre-treatment. Even aquaculture process cannot work if you don't have a pre-treatment system. The worst why a natural treatment system have historically been not, performing well, because people change their mind to understand the terminology of low maintenance to no maintenance. So they do no maintenance, therefore they stop working. The third is DP, duckweed ponds. This is also a type of constructed wetland which is called free flow system. So here macrophytes like duckweed ponds are used. Here you have added advantage that duckweed that is produced can be used in the poultry, and the treated water can go to aquaculture, which can be used for the pisciculture and things. So we need to devise certain treatment system which are not only having minimum mechanization and minimum operation procedure, but it should also be producing a water which is useful for the community's economic activity, so that they will feel that as a part of their system and they will manage it. So out of all these systems, there is some drawback for WSP that it require at least 4 square meter per capita, population, and similarly there are some problem with the USB and polishing pond system. Like if you have a USB system, it becomes anoxic condition. So normal polishing pond will not work. You have to put aerators. So again, you are not minimizing the cost of operation. And in some cases, your COD COD at the inlet of the USB is relatively very low. In those conditions, USB may not work. There are some success stories in India for USB based system, like there is a 92 MLD plant in Nasik. It is operational now and they are going to expand it. But in all other cases, wherever I have seen USB based STPs, they have not been working for one region or another. So the best option is the constructed wetland that we should go. Constructed wetland has got so many modification, and the thing is, there has to be vendors also, there has to be people who can install it and who can operate it. So now in all part of the country, there are vendors who are able to install it as per the client requirement, manage it on a like for other conventional system are getting the operation contract, they can get operation contract and they can manage it. So that is how I feel, and even Government of India and other agency, they are feeling, including CPHO, that constructive wetland could be one of the technologies which can be adopted in some cases independently and in some cases in combination with the uh, conventional engineer-based systems. So before we get into the constructed wetland, first we should know that why constructed wetlands are so important. So constructed wetlands are wetlands, typical wetlands. So there are three kind of systems that we see on the earth. One is, second is the deep water ecosystem, and third is the amphibian, the wetland system. So if we review the hydrology, the terrestrial ecosystems are dry, deep waters are permanently flooded. However, wetlands are intermittently to permanently flooded. Therefore, they work as a source, sinks, and transformer, and their productivity is generally high. So, more the productivity, more the contaminant removal. They have been working as these wetlands have been working as a buffer to majority of the cities, coastal cities, and you might have seen the problems related to flooding and other things has started in Chennai and Mumbai and Cochin and other coastal cities where these wetlands have been disturbed. Okay, so in the constructed wetland, what we do, we engineer those characteristic of the wetland, bring into the terrestrial ecosystem, make the hydrology and other things as per the requirement, and then we put it in use of the well-being of the humankind, here in this case for the treatment of sewage or industrial wastewater. So in this case, we will be only talking about the treatment of sewage using constructive wetland. So constructive wetlands are of two types. They are free flow or subsurface flow. There are benefits of free flow, but there are some problems also associated with the free flow, wherein you may get problem related to the mosquito breeding and other things. Therefore, the recommended option is a subsurface flow, where wastewater is not exposed to the air. It is always channelized within the gravels and all. No. The mechanism of working of the constructive wetlands are like everything happens in the root zone, which is called rhizosphere. The roots of the wetland plants, they provide oxygen through active and passive aeration to microbial community. The roots die up also act as a nutrient to the microbial, and physiology of the physiological other things of plant physiology that gives water to microbial community. They get strength with all these basic nutrients, and then contaminants are degraded to harmless products. So this is called enhanced rhizospheric biodegradation. So biodegradation happens whether it is activated sludge process or it is MBBR and other biological processes. The main agent of the treatment is the microbes that are there in. Okay, but here in this case also microbes are there, but there is a assistance given by the rhizosphere in the root zone area. That is why it is called also root zone technology. There are two components, the biological and non-biological. Biological components are plants and microorganisms. What plants do? They stabilize the substrate and limit the channelized flow. They make the system cyclic against the conventional linear system of wastewater treatment. So some of you might be hearing the discussion of circular economy and other things. So this constructive wetland technology also gives a safe where cyclic pathway of treatment is there. They transfer gases between the atmosphere and the sediment. The oxygen is get transferred from their photosynthetic canal to the rhizosphere, provide site for the microbial attachment. Microorganisms, they transfer organic and inorganic contaminant to inoffensive or insoluble substances, mediate the pathway of nutrient recycling and mechanism. So when they put it in insoluble substances, that gets filtered and that can come out. Non-biological water hydrology, most important design factor is the hydrology, how you are maintaining the hydrology. There has to be proper flow regime maintained into the bed, and then this is high regularity and can have fairly significant impact on our wetland and on its treatment efficiency. As I said that, I mean the hydrology of part of this, I mean non-biological aspect is very important, and it has to be done by a expert of that area who has done the practice in that particular region. Substrate, sediment, litter, and gravel. These are the other non-biological items. Like many chemical and biological transfer take place in within the substrate, whatever the gravels and are put. The accumulation of litter increases the amount of organic matter. Even the size of the gravel, size of the sediment, size of substrate, that is very important to avoid clogging. Organic matter provides sites for material exchange, microbial attachments, and in some carbon, in a source of carbon, the energy source that drives some of the important. So the carbon source is in the form of the natural organic matter (NOM) that is attached with that particular, I mean, substrate that are put in as a sediment, litter, or gravel. These are the typical plants like Canna indica, Phragmites australis, Phragmites carca, Glaciaria maxima, Baumia articulata. Phragmites carca is also there. Canna indica is now typically being used. It can be used with the other many plants. So, I mean, you can convert your wastewater treatment plant into wastewater garden. I will show you some of the pictures of the examples of, I mean, companies known to me who have put in Himachal Pradesh and other areas. So what exactly the design steps are for like any conventional, I mean wastewater treatment plant, we need to define the treatment requirement. Whether we want to do the treatment to achieve X number of BOD or we want to use for X type of reuse requirement, which standards we need to follow. Accordingly, we'll have to start doing these things. And what is our outlet condition? We have to characterize the wastewater also, other than the standard requirement. We gather background information related to, I mean, how many users are there, what is the typical fluctuation of the flow and other thing. Then site is evaluated, which is if suppose there are options given that these are the sites that you can do. So you can do, I mean, SWOT analysis for the site related criteria. I mean, optimally the sites which are having some gradient, some slope. So you can minimize, I mean, your cost in pumping during the operations. So that kind of, I mean, site can be selected. Determine the pre-treatment level. As I said that, I mean, you cannot directly put the, I mean, sewage into the, I mean, reed bed. You have to give some pre-treatment. That pre-treatment could be like preliminary treatment where we do screen bar and then you put a settling tank, which is also act as a equalization tank, or you can have an anaerobic, I mean, unit before that. The anaerobic unit also helps to, I mean, bring down certain recalcitrant compound that comes along with sewage, because in some of the cities we get industrial intrusion of the sewage. Even in from societies and other things, we get surfactant and other things. So that can inhibit the microbial growth in system. That is also applicable to our mechanical system, but here because they are plants, they are more sensitive. Determine design parameters. Yes, so this is already discussed. Vector control measures. If you are going for the free flow, if you are going for subsurface flow, if your system works properly, there is no, I mean, feasibility. There is no probability of getting any vector-related problem. And then detailed design of the system component, and accordingly we go for process. There are several potential applications for the, I mean, constructive wetland. These are used as advanced treatment for nitrogen and phosphorus removal. They can also be used for heavy metal and refractory organics removal. They can be combined with the secondary and advanced treatment also. They remove BOD5, TSS, pathogen, nitrogen, phosphorus. They can be used for habitat development. enhance and they will be enhancing the environmental resources, irrigation return water, landfill leachate, reclamation of water use, secondary treatment, septage, and stormwater treatment, so on. I mean, majority of the lake rejuvenation program, you might have heard that they are now, provided a buffer alongside the lake with the constructive wetland. So the stormwater comes to the constructive wetland first, then it goes to lake. In summary, the performance of constructive wetland is discussed in this. So BOD, we get 60 to 90% reduction in the constructive wetland through enhanced rhizospheric biodegradation, through nitrification and denitrification. It is 25 to 50% in cold climate and 65% we get in hot climate. Phosphorus removal in cold climate 25 to 50%, in hot climate up to 74% in India. TSS removal is up to 75% is done, but this also sometimes TSS may inhibit the work, so there has to be pre-treatment required. Pathogen and coliform 76 to 99%. They are easy to operate, cost effective, and most importantly, they are aesthetically pleasing when they are in operation. Now, worldwide, there is a problem that we have already discussed the first, that too much generation and less treatment. So options we have: mechanized treatment system. So MTSs are more energy intensive. Mechanical treatments and requires lower land compared to NTS. So that is the merit with them, that they need lower land. But in either case, to challenge the achieve environmentally benign and viable cost-effective treatment, so we'll have to just see that what is better and what is not. So recently, IIT Bombay has done some research on all available treatment technology, and they have compared it. So you can see that CW1, CW2, and MTS part. So it is different combination of constructive wetland has been. Some CW1 is the constructive wetland which are used directly, and CW2 is just after secondary treatment. And then MTS, you can see inlet BOD, if we consider 30. So outlet BOD, to achieve outlet BOD, our cost, you can see in the other location, it is for MTS, it goes high if you want to bring down to a lower level. But for natural treatment system, it gets streamlined. So specifically, there is a delta from where we should try for going for natural treatment systems. Now, if you go see the land requirement, in the land requirement, natural treatment systems requires more land if you want to go down in this area. But for MTS, you can see that it is more or same, it is going over there. So there is one again a factor from where we can see that at one particular location we can have a combination, and we can use primary and secondary treatment system as a mechanized, and then we can have constructive wetland. So we will be able to achieve the requirement for that. So, yes, up to 30 we should treat with the mechanized treatment system, and then after that we can use this part. This is for operation maintenance. Similar comparison has been made here. You can also see. So the proposal is to have a hybrid treatment system, specifically for the class 1 towns. Below class 1 town, we can directly go for full scale constructive wetland treatment system also. So many companies have worked on this thing. So this you can see, this is 40 KLD treatment technology. It is working in the Jaipur. The best part in constructive wetland technology is, it is not that you need a square space. Anywhere you have a space where you can maintain the flow regime, okay, there you can utilize it. So here you can see there was a space at the corner of the facility, and it could be utilized, and they could get the required treatment. This is 200 KLD sewage facility in smart city Dharamshala. So you can see that how treatment plant looks here. So already, there is a scenery around for the Simla, but at the same time, this also enhances the beauty of that area. This is another 1.3 MLD. tertiary treatment facility. So post secondary treatment, this has been utilized, and it is now achieving NGT requirement below 10 milligram per liter BOD, and pathogen removal is also as per the requirement. Here you can see the secondary treated effluent in the brackish water, and then the tertiary treatment post 2.89 mld of plant in Jwalamukhi in Himachal Pradesh. And first photographs you can see it is at the time of propagation, and the second photograph you can see this is like fully operational plant. This is another for Palampur. There was another facility that was done in Haridwar. Okay, it was for rejuvenation of the lake. Okay, here typhoon, here again water lily was used, and this lake was almost non-existent. It was only getting flooded during the rainy season, but that through application of this they were able to revive the
First, I introduce myself. I am Venkatraman, Tamil Nadu, from Tamil Nadu. I'm a basically construction civil engineer, but my master degree in environment, ME environment. So I am interested to the environment sources and also society activities also, construction based, and also I am the registered valuer also. I completed my IBBI, Insolvency Bankruptcy Board of India, MSc valuation also. But we are the practicing engineer. Other than BE, we took ME structural and construction management. I studied environment. Before that, I interested in this area. In my house, 2006 onwards, three things followed. One is we are drinking only rainwater only from 2006. How to I convert this one is before we conventional method, they collect the water from cutters and stored in drums and hot and filtered and drink it. Same type, I converted to collect the water. We studied what is the filtration method. First one preliminary and secondary, third one tertiary. Preliminary, how to preliminary treatment is clean the rooftop, then collect the wall. First water is wall is in straight, the silt and dust are removed from the drainage. After filtering, close the valve and send to the sump well. Before that sump will go to the sump well, I construct the one of the filter bed. It contains the medias, filter medias. Just whatever we have, in the construction area, jellies, bubbles, and aggregate, small aggregate and 20 mm jellies and filter medias, sand. Before that, collect and also charcoal. Charcoal. We put it. Some of the 60 centimeter to 80 centimeter, each 20 centimeters, and collect and filter it. This is suspended particles are removed. The secondary treatment. Then it is passed to the sump well. Sump well automatically one of the sedimenters also is taken place. Secondary. Third, this is then pumping to the water tank. The separate tank also installed. Individual pipe to the sink, kitchen sink. We don't have a RO plant, only UV plant. So the rejected water is negligible. No canned water used. 100% all are mineral content. No saline water. So 90% of water is filtered. We have here when the average rainfall is near up all over India, 900 millimeter. In house, 4 to 5 members, we inhaled the water, we drink the water near about 11,000 liters. We received the water from rainfall in 1,000 square feet. 1 centimeter is equal 1,000 square meter. 1 centimeter rainfall is equal to we receive the 1,000 liter of water. So we want 11,000 liter of water in per year. But rainfall is 900 millimeter, 90 centimeter. So 90,000 water we receive. Only receive the sump. I construct the sump 10,000 liter. It is 2 compartment. One is rainwater, another is municipal water. Municipal water is using for the domestic purpose. Rainwater collection for the drinking purpose. I collect the water, rainwater, twice the year. So 5,000 plus 5,000, 10,000 is enough to the drinking water throughout the year. Excess of further 90,000 liter of water minus 10,000, I say 10,000, 80,000 of water to the borewell. I sent to the borewell. In borewell, it is just chamber, 2 by 2 chamber, 2 feet by 2 feet, and depth of 2 feet. It is all to the filter water. It is filtered and overflow water so is sent to the borewell. This is always 2006. This process are going in usually order, and this method I throughout the year, throughout the city, I give the guest lecture to the colleges and social medias. Awareness, give the awareness guest lecture to the awareness program and give the article to the Tamil newspaper. I am in the fluent in Tamil, so giving the Tamil magazine. Madam, I sent to you some of the slides you give. This is my specialist. This one specialist. Another one specialist also. We provide the kitchen waste management in my rooftop using the Kamba. The Kamba contains 3 layers. Even we are using waste out of 100, 50% is from the kitchen waste. This from the all are organic. We put in the dustbin. It's sent to the municipal waste bin and sent to the STP. As example, my project is also this one. how to case study in Madurai, 15 lakhs of peoples, 5 lakhs of houses per day, 600 ton is sent to the STP. Each and every house done this in urban area, inside in all our rooftop, they reduce the 50%, therefore 300 tons are reduced. So I put in my cards also garbage to coal. From this Kampa, all the waste sent to the day by day, 3 layers, 20 days, 1 layer, and sent to the second layer. And finally, it is converted to compost and degrade the waste, all the waste, and converted to the manure and put into the vegetables, and harvesting the vegetables, and we consume the vegetables. This is second word thing. This is my project. I give the at the conference also. I gave the paper presentation. This is all over. Where each and every person do it. It is one of the best environment, sustainable environment. So I received the best sustainable decision from the Nippon Paint and Anandavadan magazine, the ACED 2021 award. This is the winner. Third one is we don't use plastic. Always having the jute bag and carry the jute bag. So what we are the practicing construction engineer, valuer in busy schedule. This one is my passion. All the seminars attending and receiving the out input and take the snaps and slides and store it. So I repeated from you PPT wanted and store it. And convert to the PPT and present to the students and public awareness. I conduct the STP model 1 also. Ramanujams, I think Ramanujams are.
You attended that also, sir?
Ma'am?
Did you attend the model 1 also?
Yes, ma'am. Yes, ma'am. Yes, ma'am. Yes, ma'am. I think Manjunath sir, Ramanujam sir. I don't number of. I received some of the name also. You are the organizer. You are the organizer.
Yes,
I
sir.
think. Yes, from this one. Number of doctors in having our groups. Why are you did not interact with the others? I don't know. Number of questions having, but I giving the chat box also. Number of questions. We are in. You are the faculty and teaching professions. We are the practicing teachers. So we are the communicating problem also there.
Yes,
So
sir,
this
there
is a
is some.
chance. Yes.
But it really feels good if participants interact, and it makes that sense that we are conducting something, some knowledge is going towards the participants.
Yes, ma'am. We are the very excellent and eminent people you having. I from the IIT. Today the ministry today morning session. Mr. Dinesh something. This is the Kanpur. Sorry. He from IIT. I think IIT professor. Yesterday also. Yesterday this is important one. I feedback given to you. What is the process given by the Graha and lead? And the ma'am said only the numbers. The numbers said to the sustainable. The numbers giving the points. Ma'am, there's also yesterday. So first third session. Some of the we are 100%. We are not attending, ma'am. some of calls.
Yes, sir, we can understand it is not possible to be present all the time. That was the reason why I keep sharing links for the videos. That even if you miss, you at least know that what was being conveyed.
What I said, you split up the days, weekend days, or daily 2 hours, 4 to 6. It is useful to other than students as we. That's why I.
Thank you so much, sir, for the suggestion. Yes, sir. I got your point. I got your point that instead of keeping it for the whole day, keep it for a shorter duration and for a longer number of days.
Next one, ma'am. Next one, you concentration to the student. But we also be concentrate to the us our side also you.
Definitely, sir.
Yeah, the stockholders. Yes, ma'am.
Definitely, sir. Your participation is really important because that conveys the message to the people who are actually the need of the app. You are the only person who will convey all this knowledge to practice, and then that will be conveyed to the people. That's really important, sir. Thank you so much for participating.
I giving my PPT to your personal lady. You
yes, sir. Surely,
you
sir.
use it and refer it, ma'am. Thank you. Thank you. Thank you. Thank you, ma'am.
Thank you so much, sir.
Thank you.
So I thank you. I thank Venkatraman sir for his valuable feedback. Thank you so much, sir. We will definitely think of organizing this program for a longer number of days and a shorter duration in a day. Now I think we should get connected to Subramaniam sir from Malaysia. Just give me a few minutes so that I can get in touch with him. I would like to inform the participants that we cannot request each and every speaker to share his or her works PPT because every time it is not possible. But the information which I have, I've been always conveying it to you. So that is the reason why I usually keep recording the sessions and sharing the links with you because nowadays every speaker doesn't agree to share his or her PPT. So whatever information I have, I will be sharing with you. But in case most of the sessions I don't have the PowerPoints, so I have shared all the links with you. Still, if you want, I will give you all the links, and that will be, I think, active for around 15 days. After 15 days, it gets deleted from the Microsoft Teams account. So even if you want to have a look back at the sessions that being conducted or in the information, you can log into the links, but that is available only for a limited duration of days.
Hello. Good afternoon, madam. Am I audible?
Yes, sir. You're audible, sir.
Uh, this is Professor M.A. Modi from MS University, Civil Engineering Department, Faculty of Technology Engineering, Gujarat. First of all, I'd like to congratulate Madam, specifically Dr. Jagwani, and also along with you, Lalit sir, and I have also attended the previous session 1 week before the Diwali. That session also I attended. I'm having just only two suggestions. One thing that being our senior faculty in the department, our junior assistant professor and many other faculty need 2 week continuous STTP to attend, specifically sponsored by AICTE. So that is what just one suggestion. Even before starting this first week, I have also suggested this, that if it is possible, then AICTE recognize at least 2 week STTP is must for the newly joined assistant professor in the department. And second thing, the session was quite good. Many of the session I have attended, some of the session I missed. I'm sorry for that because simultaneously examinations and something is going on in our department. Important sessions when I have attended, but Mr. Sudhir sir, Surendra sir, Sinha sir, I think from groundwater, Delhi, specifically, he has explained lot most important informations what it is not available on internet. He has described all the various contaminants available in various parts of the Gujarat. Though a lot of informations are there on the CGLW websites, but certain specific things are not there. One important suggestion I would like to say that, there are a lot of work has been done in the field of groundwater engineering, specifically as a geologist and as a civil engineering department faculty. We have seen that we are also incorporating work with the groundwater engineering. But the thing what we find that is lacking in the area of remediations. So I would suggest if whenever you are framing for the new STTP and you are inviting various speakers, then I would like to suggest you very good speakers are there at IIT Roorkee. Those are involved even this time also. I have seen few faculties were there from IIT Roorkee, but they have done a lot of work in remediation, specifically groundwater on the large scale. I'm not talking about the micro scale. I'm talking about the macro scale. So this is just only a suggestions because, in our Gujarat, we are specifically central Gujarat, we are suffering from the nitrate and fluoride a lot. And we do not require any micro project. We require a macro level solutions. And that is what it is a little bit difficult. And a lot of research is going on about that. So once again, I would like to congratulate Madam yourself and all the participants. I'm sure that, the participants have gained a lot of things. Thank you very much, Madam.
Thank you so much, sir. Definitely, we look forward to having some remediation part in the future. Actually, AICT short-term training programs are supposed to be of only 6 days a week. But what you're talking about, 15 days, that comes under faculty development program. So those are also sponsored by AICT,
Yes.
but short-term programs are usually for 1 week only. So that was a constraint we were facing. Last time we tried a lot to make it a 15 days program, but we didn't get that permission from AICT. They said that we have to go for 1 week only. So that was the reason why there
Never
was
mind.
some problem also. But we were in fact trying this to be a continuous one. That's what we tried to, but we had to split it up in two parts.
Okay.
So that comes in the faculty development part, sir. So that's what AICT had suggested, that if you want to go for a 15 days, that will be in a faculty development program sort of thing. So thank you so much, sir, for interacting and giving your valuable suggestions. So I
Yeah,
thought
thank you very much.
thank you, sir. I look forward to meet all the great participants in person sometime. Hopefully that will be in future soon. So I saw somebody raise their hand also. Can you please come forward if you would like to speak? So we are waiting for Subramaniam sir. He is supposed to join us by now. So in the meantime, till Subramaniam sir is able to join us, I request you all to switch on your camera so that I can take a screenshot of the screen and as a memory that we had great participants into this short-term training program. So if possible, please switch on your cameras. Thank you so much, Mukesh sir, Alex sir, Chaturvedi sir. Anybody else who would like to add up into this photo session, please come in and join us. So what promotes and motivates us is that we have participants who are willing to give their time and interact with us, and it really feels nice if the efforts we put in are recognized, and especially the information that we want to convey is being conveyed to everyone. So that was our earnest effort to bring experts in interaction with the different educational institutes and faculty members, and that also adds to our knowledge, because a theoretical world and a practical world has a lot of difference, and such type of programs brings in front of us the practical aspects that is being carried out into the world. So somewhere it makes a connection and sense that whatever we are teaching and whatever way we are moving on, that leads to some practical part. So let's hope that in future also we are able to have eminent speakers and discussions, so that in some small way also we are able to contribute in to the development of the society in a larger scenario. So as I mentioned that I don't have the PowerPoint of all the presentations. Whatever slides I have, I will be sharing with you, but I don't have all the content. And because of which I have shared the links for recording If you want, I can share those links again. And I request you to please go through that recorded material. That can help you out.
And we had to adapt a lot from the Netherlands standards, right? So I'll talk about that as I go on. And you can also participate in the question and answer session later. And then number 5, I will touch on discussion on restoration of the freshwater dam. I can't give too much of data, but some I can let you know. And in this area, it will be quite interesting because we had to do a lot of analysis on the soil itself, the soil framework that we managed to identify that was contaminated and what we did with it. And then in conclusion, and then some references at the end. All right, so I will begin with the discussion. And of course, for the rules of engagement, I would like to invite you all always safety, especially if you are driving or in what you call working from home, right? The WFH is working from home. Many of us are actually working from home. So I suppose this is something you should consider. Keep yourself self-muted during the presentation, except the Q&A session. And please actively use the comment box. I suppose Dr. Jagansi will be able to see the comment box. If there's any issue you'd like to raise, you can always raise it during the Q&A session. And lastly, please focus on the lecture and enjoy the training, right? Let me go through the introduction. So I'm sure you all like to see this kind of greenery, right? You know that you see a lot of green stuff. Water, I'm sure now you are facing. I heard a lot of heavy rains in India currently, right? I'm getting feedback. Even today morning, I had good vegetation support so that aquatic life forms can survive there. In the air, generally, birds and so on can survive there. But for the human, these three dimensions are very, very important because they support our life. So in that sense, then we have biosphere, which is near to the sea. Generally, that is why human habitation is near to the sea or near to the rivers, right, where we get water, and then we get plenty of vegetation or forests or trees where we can get our supply, all right. And from there, we develop rural habitations, villages, and so on and so forth. Until now, we have come to a urbanized world, and that urbanized world is the one that is causing a lot of problem to this biosphere. All right. Of course, we can talk about industrialization, we can talk about other issues, but all of them are hurting the environment. And we cannot forget that when you hurt the environment will hurt human life forms. All right. Besides, these issues will be not just short term; they also take a long time to develop. All right. So, in this topic, I'm touching specifically on soil because the issue of soil contamination has become very critical in many areas. All right, um, some literature shows that soil actually is very critical for human life because that is where we have our plants, that's where we grow our vegetables, our cash crops, our food crops, where we grow them there. And generally, these are, as long as not contaminated, we can use them. But once they are contaminated, then we have this problem, right, where we need to remediate the soil. Right. So in developing countries, it is part of some implemented projects with stakeholder participation efforts. Right. Such projects are, anyway, this study is published by O'Brien, Phelan, Smith, and Smith, 2021. Such projects are in the areas where they have risk, right? They have pointed out 5 risks, right? Number one is the human exposure routes. Now, the human exposure route is related to, if we are talking about the air, we are always breathing in, right? So we can get exposed from that. Then if you are related to food intake, we drink a lot of water and we also eat food. That is also another route. We call it the ingestion route. And then we have the other routes, for example, through exposure to the dermal area or skin contamination. So these are all parts and parcel of human exposure routes. The second challenge will be due to poor funding, right? This is due to the legacy of pollution. Right? We have a lot of what you call contamination happening, but because of poor funding, we are unable to solve this legacy of pollution. So to do that, we need to have proper policy, we need to have proper funding, and so on and so forth. In Malaysia, currently, we have a program called cesspool fund, right? Cesspool is actually cess fund. This cesspool fund is actually taxing the what you call large industries or small industries, and we keep them in a fund. Then from the fund, we use that money to actually do cleanup work and so on and so forth. All right, but it is being practiced in a very shallow manner. So I don't think they are able to do a long-term, what do you call, remediation work. But in this particular project, the funding was done by the land developer. So later I will touch on that. Right? Then the third point is on informal living, what do you call it, informal livelihood occupation with political and economic instability and also weak regulatory structures. Informal livelihood occupations, there are many, right? Some, for example, people who live in the rural areas, right? They are not able to support themselves. But without political support and economic, with poor economic stability, they have this problem, right? And the weak regulatory structure is based on our what we call enforcement, right? We need the laws or policies which need to be enforced properly. Then the remedial efforts use actually simple, cost-effective methods, and basically they use methods like excavation, safe storage of polluted media, where the contaminated soil with heavy metals and persistent pollutants are kept, right? This will be a major problem for everyone, not just in Malaysia, but also in other countries. I'm sure you all would have come across some of these examples, all right? In my project, what we did was we evaluated a site. We managed to remove the soil to a different site where we make sure that contaminated soil stays there forever. All right. So it was actually a highway project. So we used the land as refill for the highway project, and we used the good earth for land reclamation work or soil reclamation work. We will touch on that as we go on, right? Okay, as part of this introduction, so what is the state of the remediation in developing countries? This is just for general discussion, right? Generally, there are many routes, right? There are many routes where this remediation work takes place, right? Among them are the hydrocarbon pollution, then you have the legacy of contaminated or whatever uh, price tags that are placed on them. Then you have in the center, you have lead contamination and use lead and batteries recycling programs, for example. All right, and you have the e-waste recycling programs. Then you have the stakeholder engagement. Then you have the small and medium in mining as well as industries. And these are all the informal sectors involved here. And of course, at the end of the day, we have public participation, right? Without this, we will have question marks left around, right? How are we going to face this problem without the support of the public? All right. Especially if you go to any waste dumping ground, you can see a lot of these recyclers or so-called recyclers there. But these are informal sector, all right? They are not properly trained. They do not have proper competency to handle these projects. So this will become a danger to themselves and also a danger to the public around them, all right? Let me go to that later. All right. This is something that you all publish in your portal, all right, regarding this water, the function, water quality resources that you all like to restore, conserve, manage, and maintain water bodies, and also the whole system, especially the biosphere. This is very, very wholesome, very large, and your focus is only on the water. I understand that. All right. So you all are worried about water as a media for survival. All right. But anyway, we will see how it works in this project. Okay. So before I go into the review, so far, so the introduction is just general, right? Just want to let you all have a view. I'm sure you all have your own views, but that is the general view, right? I'm just going to talk about Malaysia, for instance, all right? Because I don't want to talk about other countries, so be better in that way. Malaysia is basically a small country, which basically was dealing with agriculture, all right? So agriculture was our main activity for a long time, right? They have rice, they have oil palm, they have rubber, they have cocoa, then they have other food crops or fruit crops, all right, vegetables and so on and so forth. This is very suitable for vegetation because of the equatorial climate. The soil is quite fertile because you have a lot of clay, you have a lot of what do you call humus, right? Manure is available, free manure, right? So you have a lot of vegetation, so you get a lot of free manure. But unfortunately, along that period, we wanted to industrialize. So we introduced mining, small scale, big scale mining for both tin mines. Then we have iron mines, we have gold mines, and lately we have also have aluminum mines coming in, and all of them have got their own impacts on the environment, right? So these together with urbanization, right? If you take the place I'm staying near Kuala Lumpur, right? The whole of Kuala Lumpur has become a megapolis, right? We can go travel about 60, 70 or 80 kilometers. The whole area is fully developed, right? They have no vegetation anywhere. They do not have any farms or anything like that, right? Everything is buildings and so on and so forth. So this area, urbanization also play a part in contamination, right? Because of the contamination, we are dealing with another dimension of contamination. For example, waste, right? Solid waste, hazardous and toxic waste. Then we are dealing with sewage, right? And then we are talking about polluted rivers and so on and so forth, right? So our water contamination is also critical also. Right? Every now and then we have water, what we call loss because of pollution, right? So this is something that that is also coming into an urban area. All right. Okay, let me go into this review in short. Okay, generally the guiding principles for any contaminated land management and control, we have these two main guiding principles, all right, in environmental management. Number one is the polluter pay principle. We would like to get the polluter or the landowner owner or the property occupant or the user or the chemical product or waste owner to pay for that pollution, right? So that is in principle. So this is similar to 530 or 75, then you have to act. Now, if you look at the Dutch pollutant standards, there are actually so many here, right? Metals have 19, inorganic substances they have 4, aromatic compounds 7, polyaromatic hydrocarbons they have 11, chlorinated hydrocarbons they have a whole range there, and then you have pesticides, the whole range, then you have other substances around 15. All in here for this whole lot here, which they monitor and look at. When we were doing our studies, we too came across all these past contamination history on the soil, right? So these guidelines give us a very good reference point, right? Okay, so this is an example of groundwater based on the Netherlands standards. All right, these are water present beneath the Earth's surface in rock and soil pore spaces and in the fractures of rock formations. Of course, the unit of rock in unconcentrated deposit is called aquifer when it can yield a usable quantity of water. The depth at which the soil pore spaces of fractures and voids in rock become completely saturated with water is called the water table. So these standards are actually, I'm just showing here the illustration, right, where you can see the bore wells, right? They have different wells also, right? So the 1, 2, 3, and all that are all the different, but they also have 2 wells coming down, right, from here, all right. These are the wells they use for assessing underground water. But in soil contamination studies, they don't use that well. They will use bore wells or boreholes, which are used for extracting the soil. All right, I'll come to that later in my presentation. Okay, I think these chemicals are concerned, all right. Arsenic and fluoride, all right. Around 1/3 of the world population drinks water from groundwater resources. 10% approximately 300 million people obtain groundwater, water from ground, all right, which are heavily polluted with arsenic or fluoride. These trace elements are derived mainly from natural sources, all right, nothing to do with contamination, but they are leaching from rock and sediments. But new methods of identifying substances that are hazardous to health were introduced. In 2008, the Swiss Aquatic Research Institute, or presented a new method, right, by which hazard maps could be produced for geogenic toxic substances in groundwater, which provide an efficient way of determining which well should be tested, right? And in 2016, the research group made its knowledge available in the groundwater assessment platform, or GAP. This offers specialists worldwide the possibility of uploading their own measurement data, visually displaying them and producing risk map for their choices. So GAP can also share knowledge, all right, between countries and on how to identify soil contamination. At the same time, we're looking at methods of removing toxic substances from the groundwater. All right, just for our knowledge. So these modern standards also deal with soil survey for business sites, right? If a business activity in my project, I was dealing with business activity, all right, and also in a way buying and selling. I'll touch that later. But the business activity may cause soil threatening substances to be released into the soil. Let's say we want to start a new project, all right, where we want to build a biotech or vaccine production facility, a pharmaceutical, for example. So what they do is they will oblige, right, to have a soil survey carried out or baseline survey before this pre-startup to record the soil quality at that time. They don't want the contamination from the soil to infect the plant. So upon the termination of this business activity, we must also do another soil survey to carry out a final survey. If the report shows that the soil was impaired or contaminated by that business activity, we have to take the remedial action. Now, I think I used a simple analogy of pharmaceuticals. Now, let's say we use an analogy of nuclear power plant. This will become very interesting, right? Nuclear power plants have a lifespan of about 50 years to about 75 years, right? But the site has to be closed down for roughly about 1,000 years, right, before we can even think of using it back again. So you can imagine the period of time we need to do the soil surveys, all right, and the final survey will take maybe centuries to complete. And that is just for your knowledge, all right. Why I touch on that? Because when Malaysia thought about building a nuclear power plant, they invited us to give our views. So we were also sitting on the panel giving views on this. Anyway, Malaysia doesn't have nuclear power plant, so at the moment we are still green. Okay. The next point is on combining soil surveys when buying or selling. When buying or selling a parcel of land, soil surveys can also be performed, all right? They are not legally required, but serve as a different purpose to those performing activities with potential to negatively impact the soil quality, right? These two types of surveys can be combined under certain conditions. So this depends on your requirement, all right? Client requirement, of course. So in my case, my client is a big land developer, Malaysia. They own estates of land, right? Thousands of acres of land, and they wanted to develop a particular piece of land. So they asked us to conduct a soil survey, and then they want to see if we can do something about land remediation because of that, right? Okay, so since we have come to about 1 hour of talk, right? So I would like to give 2 quizzes, right? So the first quiz will be here. Dr. Jagansi, are you there?
Yes, sir.
Yeah. So you have distributed the slides to everyone, or are they just getting the slides now?
So I have not shared it. They are just having a watch on it right now.
Okay, okay. So if they have no access to the slide, how are they going to answer these questions? It's going to be very tough.
No, sir. We can give them a few minutes so that they can search out for the answer because these are common concept questions, I suppose.
No problem. So I tell you what, the participants can answer the questions, and then can they email the answer to us?
Surely, sir.
Okay. So I don't know what's your email, but I will type in my email so that they can. Don't type this as the answer, okay?
So the participants are requested to send answer to the questions
Yes, please.
that have been given in the quiz.
Yes.
If they can answer right now in the forum, it's great, so that we can have a conversation sort of thing.
Yeah, why not?
So,
It depends on your. If you want to have a question and answer, can. If you want the email to be the answer, we cut short the time. That's all. Up to you.
so anybody who can give what is the polluter pay principle or can explain what is the risk-based approach, you're welcome to speak. Or else if you would like to send the answer to this question, the email is given by sir. So we have a response in the chat box
Okay.
that those who create or generate pollution has to pay for
I
that.
can see your chat box, you know. I don't know why I can't see it. 1 minute, 1 minute. Let me check. Give me a minute. Oh, okay. Yeah, I can see the chat box now. Vignesh Bharati, right? Right.
Yes, sir.
Right. Those who create the generate pollution has to pay for that, right? And must pay for the remediation. Okay. Somewhat right. Yes. And
And anybody who can give the answer to risk-based approach.
this
What
approach.
is a risk-based approach?
Yes.
Please respond in the chat box if you know what is a
Yeah.
risk-based approach.
Yeah. No problem.
Very rightly said, Vignesh sir, that those who create or generate pollution have to pay. They have to give a penalty. That is the polluter pay principle.
Correct.
And identifying risks in a process is again given by Vignesh sir.
Identify risks in a process. Huh? In this case, land contamination. So how do you use that in a process? Because the land is contaminated. Yeah, actually it's okay. Don't worry about that. Yeah, the issue is we want to know whether the contamination is high or low risk. That's what immediately we are looking at. If it is high risk, then we need to take action based on that. So that is base analysis is supposed to be doing that. Right? Risk assessment is being used in many contexts. Right. So in soil also we were using it. I will show you later how we developed it, but it was a bit of a tricky situation because there are too many chemical parameters there. So we had to be careful when we were doing the risk assessment. We cannot blame the landowner. The landowner never realized the contamination was there because he has a history. He's been buying this land from other people. For example, you are a big land developer, so you buy the land from someone, but you never realize the land was contaminated. So they were very innocently, they got caught. Right? So we have an international client who required that to be done. So the local guy didn't realize that, so they had to what do you call pay for that analysis and also the remediation. But anyway, that will come later. Right? Okay, fine. I think can we proceed with the next part? Or do you want to take a short break?
Yes, sir. We can take a break of 2 minutes.
Okay, thank you. We'll take a 2 minutes break. I'll come back to you quickly. I also need to have my drink. Thank you.
Yes, sir. So participants, I'm sharing the PowerPoint given by Subramaniam sir in the WhatsApp group. And I request you to please open it and go through it.
Are we back? All is everyone back here?
Yes, sir.
We can begin?
Yes, I've shared your PowerPoint as well to the participants.
Yeah, it's fair, you know. It's fair. All right, the quiz has not finished, you know.
Mhm.
There's another two more questions. Why do we conduct soil surveys for business sites? Maybe y'all can put the answer in the chat box. Okay, we can have a look. Let's see. After the short break, do we have any answers?
Yes, can you please, participants, tell why we have to conduct soil surveys for business sites? Because we have practicing civil engineers also in the group of the participants,
Sure.
and you all are very well aware that why do we have to conduct soil surveys. So please let us all know that why soil surveys are essential for business sites.
Business sites, yes. You can just type into the chat box.
So we have an answer. Vignesh sir again has responded to the question and he says to know about bearing capacity level of contamination. Also, Venkat Raman sir has also pointed out that SBC and minimize the cost also.
Yeah, sure. I know. All right. No answer is wrong. Because definitely you're going to bear the cost. That's the main. You want to do the contamination study, it will be very useful to minimize the cost in future, especially for the clients. So anyway, that is okay. I won't go further than that, but it's also part of the due diligence study, right? So sometimes you need to do that for your clients. Then number 4, I would like to ask is why combine soil surveys when buying or selling land? Why you need to combine that? The answer I just gave earlier, is there in the slide there. Why you need to combine? I give you the answer.
So the answer is in the PowerPoint which I have shared by Subramaniam sir. If you can browse, if the participants can browse, they will get the answer in the slides only.
I always give the answer first, then I give the question.
So that actually is helpful in making out whether the participants are hearing and paying attention.
Actually, that is in adult teaching, we use that method. We give the answer first, then we ask the question. It's okay, all right. So nobody seems to be answering, right? Okay, never mind. We leave that question for another time. I will proceed with the next part of the presentation. All right. I think we will run short of time. All right. The first part was on called soil contamination or land contamination and related issues. Now I'm going to talk about environmental impact assessment. Now this is related to what we are going to do in this project. All right, so I need to cover this. All right, so EIA, I'm sure you all are familiar. Some of you may be doing it. All right, you identify, predict, evaluate, communicate information about impacts on the environment of a proposed project, and then to detail out the mitigating measures prior to any project being approved for implementation. Generally, this is same anywhere in the world. All right, so in Malaysia, the Department of Environment came out with this long ago in 1987. Then after that, they reviewed that and came out in 2015 with a new prescribed order. All right, after that, we have come out with these new standards. Now, what they do is when you look at the EIA, right, they look at some issues, right? Among them are the issues of stakeholder empowerment, international changes, corporate changes, design engineering changes, and scientific changes. All right. So all these combined then only come into EIA itself. Right. You cannot just look at design and engineering change or scientific change without looking at the other 3 areas. This may be very disastrous for whoever is doing studies. Right. Take note of that. And in this EIA study, basically, it's a very useful planning tool. Right, it gives the managers what do you call it, an educational or educated decision making process. Right, so they are allowed to know what's going on in the project. Actually, when I was doing my project, I was involved in a project where I had to deal with the CEO of a company. All right, so this CEO wanted to know what is the actual impact from this contamination, how it's going to have health issue, and then whether it's going to cause any problem for the project design and so on and so forth. So they were just trying to do initial earthwork. At that time, this problem came up, right? So that is why we do that. So what are the considerations prior to an EIA study? Well, phase 1, you do project concept and site selection. Then phase 2, you consider the legal requirements of that area. All right, each country have their own legal requirements, but generally you have to consider them, whether it can be from the local government, the state government, or the federal government. And then you have international also issues that may be related to this. Then phase 3, you look at the EIA processes itself, where you may have different processes happening. All right, some may require simple studies, some may require detailed studies, right? In phase 4, they have baseline studies and residual significant impact assessments. And phase 5, you have to look at the mitigating measures and monitoring for the long term, right? So these are the major considerations prior to EIA study. Once it is done, then you go to the project site selection, right? Now, if I want to do a soil contamination study, so that particular site has been selected for certain reasons. But the reasons are like this, all right? One is, as a general criteria, they are looking at the buffer zone, right? They want to make sure there's no issues of industrial waste, what do you call toxic waste, or maybe some other chemical compounds coming from the particular soil. Then looking at potential impacts to air pollution, odor, water, noise pollution, solid and toxic waste, and other problems. All right. The third one is environmental control problem, which are expected in many cases, all right, especially if you have neighbors and also to improve relationship with your neighboring companies. All right. You could have neighboring residential areas who have a lot of issues. Right now, why I am very particular about this buffer zone is because of that. Right, I was involved in another study where residential association were complaining about industrial area. Right, and what happened was the government approved a residential area after the industrial area was constructed. So this became an issue. So they actually encroach into the buffer zone. This is what happens when you have a conflict between the federal government and the state government laws. Right, the federal government says have the buffer zone. But the local government says, no, we want to have the industrial housing near to the industrial area so that the people can get job and travel to work and so on and so forth. But they never consider the pollution impacts, all right, and the health effects. This become an issue later for them. Okay. The other issue in the general criteria is looking at air pollution, right? Citing in areas where air emission will seriously affect local community should be avoided. All right, so here we're talking about locating point sources of pollution and also fugitive sources. This is to minimize air pollution and all the impact. All right, purposely I put there the waste dumping ground with all the industrial area around, right? This will be the main problem that we are going to face. The other general criteria will be proximity, right? How near or far away, right? Or how distant are they from the potential receptor areas? Actually, the picture I put there is a small picture of what happened in Malaysia, right? About a couple of years ago, there was what do you call air pollution incident of industrial area, right? So this is a small school, primary school there.
We have still a lot of participants if you can unmute your mic, it will make the audio better. Sir, as of now we have 20 participants. 18 now, sir. Yes, if anybody would like to raise a question with your question, you can also type in the chat.
Thank
should be around 15 minutes.
Only 15 minutes. You have been there for 10 to 15 minutes.
Can you please answer what were the changes that you have already discussed in previous slides?
Yeah, what is this? This is 15 minutes. Mr. I see this is 15 minutes. What does it mean? Actually, Mr. you should recognize Ratish, please come. Now, this first topic now, okay? Let's start with microplastics and plant types, right? This means the participants that Mr. Manoj is not correct, right? This is first topic, right? And this is what will continue with all the different topics, right? So we cannot take too much of your time, right? Now, this is just 15 minutes of the topic, right? Now, coming with that, we are going to first the conversation part, right? Right? Towards the conversation, simple short classification. So we have fragmentation, okay? Minor precipitation. Then we have historical precipitation. Then we have transformation, fragmentation, okay? Laboratory wastewater, and wastewater discharge. So these are the first topic. Hopefully the questions are not there. So that is all that is from my end. This is appreciated. Thank you. Next question starts immediately. Thank you, Mr. 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 Surendra. Mr. Surendra. Can you please unmute yourself? Surendra, please unmute. Unmute yourself. Unmute yourself. Surendra, please unmute yourself. Surendra, please unmute yourself. Right? Surendra, unmute please. Right? Unmute yourself. Unmute yourself, Surendra. Is at each meter, right? I will show that in the sample later. All safety protocols were followed by using appropriate personal protection equipment. And then we have sample composition procedure. The soil samples were actually collected in glass bottles, which were labeled with date, time, place, based on composite sample denoted as S of soil collected at each meter in the 10-meter boreholes, which were dug by mechanical geology crews. And after that, we actually stored what you call sealed bottles, stored below 4 degrees Celsius with packed ice cubes. So all the samples were kept immediately in chillers below 4 degrees Celsius. This is to ensure stability of the soil sample analysis. And then actually the samples were collected, and then they were made into 2 to 4 composite samples by sampling at 1 to 4 meter, 4 to 7 meter, and 7 to 10 meter. So first we collected samples, then the sample 1 to 4 we put in one sample as composite sample. Then the next 4 to 7 we did the same thing, 7 to 10 we did the same thing. So all in we have 35 composite samples. Then based on that, the soil samples were analyzed for heavy metals such as arsenic and lead at the accredited lab available there in Australia. We had to get import permit, right, by the Australian government, and then all samples were packed in chiller boxes and were applied immediately to analysis then. temperatures were maintained, right, using dry ice and stored in the boxes before the flight. This was handled by the lab people. All right, later sent by courier, but flight the next day. Right. So we actually involved the lab people because they are able to maintain the temperature. Right. So this is a profile of the sample composition of the bore pits. All right. So this is for depth, right? The depth of the bore pits, and this is the site, right? The sample size. So the borehole location. So each side we have this 10-meter depth, and each meter we will take the sample, and then we will label them as, for example, C11, C12, C13. This is for sample, the composite sample. So we will know exactly where the point is for sample. All right. This is for the first 5 points. This is for the next 5 points. Right? This is over the whole area, right? Now, once we get the sample ready, right, this is how the drill was done, drilling the sampling was done. This is my one of the sampling officer. It's my student actually. This guy also assisting me is one of my lecturers, right? So they will collect the soil, and after that we will place the soil in cold box, and we pack it up later. Right? Once it is full, we will pack it fully with ice, right, to make sure it doesn't lose temperature. And then this will be stored in freezers, all right? We will send to the labs, kept in chillers, and then later they dispatch it. Once the samples went to Australia, then there they analyzed using a GSAS. Then they also came out with results. Right? Majority findings were the majority of the soil samples were found to have low levels of pollution at 18 sampling points. Right, out of the 35 sites, about 51.43%. Then the next 14 sites had arsenic pollution out of 35 sites. All right, that's about 40%. This arsenic is exceeding the Dutch threshold limit of 40% DIV. So we have to consider a place for intervention, right? So we have to map out that area, those borehole areas with high arsenic, we have to remove the soil, right? Then the next one, the 3 sites with lead pollution. Out of the 35 sites, 3 sites were having a problem exceeding the DIV standards, right? So they also have to be taken, removed. So to remove that, we map out the area, all right? What we show you is the result of the sample composition. I didn't show you the contour of the site. The contour of the site, we actually map out accordingly, all right? For example, if I see an S2, all right, if I see the red side down there, I see arsenic present, or if I see lead present, so that S2 area, S3 area, S8 area, and S9 area, all the soil will be removed, right? We want to ensure nothing is escaping to the other sides, all right? So the distance between the sample sites are more than 10 meters, right? They are not nearby, they are quite big, quite wide. So we could map out the area and remove all the soil from there for remediation work. Now, what we did was the soil that is removed from these bore pits, we actually remove it to another site. That side I couldn't show it here. The other side is actually a highway project, right, which belongs to this same developer. And then the highway developer allow us to take samples of soil there. Similarly, 10-meter deeps, and then we want to make sure clean soil. And then the clean soil from there were transferred here. And then the contaminated soil from here is transferred to the highway project. So currently the highway project is running on top of this contaminated soil. All right. So they are already enclosed inside embankments and so on and so forth. So that was not much of an issue for us. We had to make sure this site is clean from future contamination. So this soil, this is for the restoration, right? So after the soil analysis, we know that this is the area we have this problem, right? As I mentioned earlier, right? And then to do soil remediation, what I mentioned earlier about removing the soil, ensuring the cleaner soil is replaced, we did that. So what we did, we took out the polluted soil, buried it in the excavated site along the constructed highway. Then the clean soil from there was removed and used as repeat soil material for the remediated area. This took quite a while, all right. The project was about 6 months long, All right. So the study took about a month plus because we had to do sample, get the result. After we get it, then they started removing the soil and then replacing it. All right. So there was two parts to that. Then this ensured that long-term clean soil allowed for safer groundwater movement, better soil quality, and future-free from heavy metal contamination, meeting the Dutch standards. Now, this site is currently already a biotech valley. I'm happy to say that, and I'm also happy to report that there have been no complaints of soil contamination because it's still being monitored, all right, by our team. So in conclusion, in any EIA project, right, a proponent makes a legal pledge of his commitment to implement pollution prevention mitigating measures. We call it P2M2 to reduce adverse impacts to the environment. Hence, the EIA study and report serve as a decision-making tool for project approval authority. Right. Usually, it is the government, right? It's the government agency, right? For example, the ministry, the state government, local government, and maybe regional authority to make decision to decide whether the proposed project can be approved for implementation. Now, in our project, basically, the decision was made by the state government, the regional authority, and also by the clients. Okay? They want it to be done. So it is useful for everyone. All right. In Malaysia, we have this new legal requirement where we have to ensure that the EIA or whatever project that we are doing is done in a sustainable manner. All right. So that we don't have this long-term program. These long-term projects that we have now, we have major projects of land development, right? Even now it's going on. For example, land reclamation work from not just from states, but we are doing it from old mining land, right? Old mining land being converted into housing area, agriculture area. So that is being considered for this kind of soil remediation also. Major projects are in that line, right? Besides water catchment area problems. So in the next decade, we will see major change in the way projects are implemented, right? So maybe we could have a short discussion and then we can end of the day, we can close the day. Any question that you'd like to put in the chat box, or maybe they'd like to converse with us?
Anybody who would like to ask anything, please come forward.
I see Mr. Vignesh has replied again, mobilizing field visit, sample collection analysis. Yes, generally that is the method for the phases. But what I was mentioning just now, that we have actually something that I didn't put in the phase because the sensitive nature of the project, that's all. Nothing to it. But we actually did it in a parallel way. So one was on the site and one was on the highway project. But the highway project was more for refill. We needed the soil for refill. So, but that was quite expensive on the developer to refill.
Is the present condition all the projects, development projects require this type of procedure to be followed in Malaysia?
Yes. It is going on for some time because when we did, it was about it was part of this biotech valley project. So because of the sensitive nature, we had to do it not just looking at common chemicals, but we were looking at all type of chemicals. In fact, I was interested in VOCs, which they were very happy. They said, yes, it's good to look at everything. So we were looking at all types, not based on the DIV. So that was good because the site was very clean in that sense. So when we developed the biotech valley, that was the main concern. They were worried about soil contamination affecting their product in the long run. Just I want to share this with you all. When I was engaged for other consultation work, including in India. I've done consultation work in Hyderabad. So, but I don't want to mention because they're the biggest vaccine producers in India currently, right? So not nice to mention the name of the company, but they are doing a good job, all right? But they wanted to develop a project in Malaysia, and they engaged me. So I had the privilege of visiting the place in Rabat, the Biotech Valley. So the condition there and the condition in Malaysia is totally different, all right? Because in the Biotech Valley in India, they may have a different setting, right? The whole area declared as biotech valley, but I wonder whether the whole area is properly being managed. But in Malaysia, it's different, right? When we take the whole area, we do not allow any other projects to come in. We are very worried about contamination coming from other projects. That's the main reason. And then you were mentioning about, is there a limitation for excavation depth? Yes, if you set the standard at 0 to 10 meters, 10-meter depth is the standard, right? If you go below that, then it will become deep. So we were going for shallow groundwater, not going for deep groundwater. That was the main reason. I think Mr. Venkataraman was asking that question.
Sir, in present scenario, we have a pollutant which is microplastics. Sir. So,
Yes.
is Malaysia also facing the same challenge of microplastic contamination into various compartments?
Yes, yes. Actually, microplastic is present everywhere. We cannot escape. But the problem in Malaysia was we were aggravated by the so-called recyclers. There were recyclers who took on this job of recycling plastics. They were actually looking for, if you take a plastic bottle, right? Many of us we were wondering what to recycle, right? Just remember this, all right? This cap cannot be recycled. This label here cannot be recycled, but the bottle only can be recycled. But when they bring in from overseas, it's coming like countries like California, from Australia, from New Zealand. These countries are big countries, rich countries. They're exporting to Malaysia without doing the what do you call separation at source. So for us, when we received our local industries, they were in a culture shock because they didn't realize that they will be caught by this situation. So when they brought it in, so the plastics had to be resorted again. When they're doing the resorting, then the microplastics started to escape. Then at that time, this happened about a couple of years ago. Then the minister at that time, she took a very, very firm step. She said, no, we seal everything and send back to the country of origin. So that is going on until now. So we do not any plastics to come into Malaysia unless it is sorted out and as certified as recyclable. If not, we send it back to the country of origin. It's going on. We are quite strict on that.
Thank you, sir. There is a question by Venkataraman, sir. He has asked how to treat soil replacement.
Okay. Actually, he's asking about the experience that we had. What we did was initially when we did the study, we identified the polluted area, and the polluted area is, I mean, we have everywhere got pollution, but the one that we are interested in with the intervention, that was the area we had to identify. So we have to create the contour maps based on the grids. Then after that, we asked them to remove all the soil, and the fresh soil we brought from the clean area. The clean area is the one that where it was under construction, the highway under construction. We went there, we took samples from there similarly, then we did deep walls, and then we took out the soils that were not contaminated. That area luckily was not so much of contamination, so we could bring the soil and replace in this new area. So that involved a lot of logistics. We have a lot of excavators involved, lorries involved, trucks, drivers. We had to brief a lot of people. That was taking about 5 to 6 months for that. Even the small project took 5 to 6 months. We had to do it very carefully so that the soil is removed and put into the contaminated soil is actually put into the highway. All right. So the clean soil is kept in the area that we want. What parameter for contaminated soil? All right. The parameter that we use is the Dutch industrial, what do you call it, Dutch pollution standards. It is, I'm not sure whether it is there. If it is not there, maybe I can share with you. Is that okay?
Surely, sir.
I have it with me, but give me a minute. I don't want you to see the Malaysian standards, so Malaysian standards not so appropriate. Give me a minute. Pollution control. Soil contribution. Dutch pollution. Yeah, this is the one. Give me a minute. Can you see this?
Yes, sir.
You can see the values presented in Annex 1, Table 1 groundwater target values. These are the ones that we use for reference, all right? They give you the parameters, they give you the soil, and then they give you the groundwater, then they give you the standards. So, but currently they've changed this, right? This was the one that we used earlier. Currently they've changed it. They remove everything except for the heavy metals, all right? So this is based on the earlier standards, right? Not the present one. The present one is only these heavy metals. They are looking only at metals now in Holland. I don't know why they left out the rest. For our study, we look at the whole thing. All right. Any other questions? No.
Thank you so much, sir, for answering all the questions.
No problem. No problem. So,
So we have a compliment. Venkatramana sir says that it is a very nice presentation, sir.
Thank you. Thank you. These are the references, closing remarks. Okay. I just want to promote a little bit, if you don't mind. Can you give me 1 minute?
Sure, sir.
Okay. We are organizing a World Congress. I'm in the organizing committee for Environmental Health Congress. It's an international congress in Malaysia in 2022. It will be somewhere in August, right? 23rd, 25th August, the World Trade Center, Kuala Lumpur. It is actually a hybrid conference. Some of them can be done online. Some of it can be done in Malaysia itself. So if any of you would like to present papers and all that, please contact us, right? This is not in the slide. I just showed you. I can share with you later. And this is the discipline area we cover.
So definitely we would like to have the details of that.
Yes.
And
yes.
sir, will there be any participation charges for the online mode as well?
Yes, there will be. It will be not as expensive as the face-to-face, but the online one will be a bit different, slightly different. But it will be a definitely international congress because with the it involves quite a wide range of people coming from different parts of the world. But because of the COVID-19, we are a bit cautious about how you say handling this situation. Right, it can be quite tough with the COVID-19, and on top of that, we have the Congress. But we are doing it. We are definitely doing it.
The one thing we had because of this COVID-19 was that we had an opportunity to interact at an international level in a virtual mode, which was not thought about in the earlier case.
Yeah, correct. Frankly speaking, I got invited to many conferences online rather than face-to-face in the last couple of years. Since the COVID-19 until now, I've been invited virtually every month. And this week alone, I've got these two papers. This is your second paper. Just finished one on last Sunday. Someone, my ex-student, one of my ex-students, she's working in the University of Dept in Quetta, in Pakistan. So she invited me to present a paper. So we never know. People are calling from all over. We just participate. The thing is, online participation is much easier because you are able to communicate like this, but we can't see the participants' face, or we can't talk to them unless they communicate with us. This is a problem we are facing. But in Malaysia, we have already opened up, and we are doing face-to-face training. I've already done face-to-face lectures and training along with online. So it is just a matter of time when things open up. No need to worry. And I do communicate with other groups in India besides your group. There are other groups also. They contacted me. But these people are businessmen. They always call me for what do you call them? A discussion on economic roles. So I'm surprised. I'm not a businessman. I'm a scientist. But sometimes when people call, we just go along and we want to. They are trying to get ideas from. They will pick brains, pick our brains. So all of you have the same. I'm sure you all have the same line of thought, right? When people pick your brain, so that is when you become very comfortable, right? Do not keep everything to yourself. It's no point. all the education, all the knowledge you have to share. But
In
this
fact,
particular,
sir, I feel that knowledge is such a vast field that every day we are learning something new. We hear something new, and still it doesn't never get exhausted.
correct.
Like every day, the
So,
challenges are changing. So earlier we had air and soil pollution. Now we have microplastics into everything. So every day there are new challenges. Every day there are new types of diseases. Once we got facing COVID, now we are facing different types of mosquito fevers. So every day it is a challenge. Every day is a fight to survive.
yeah, correct. It's a matter of time before things get settled down. The thing is, we must adapt to the situation. The thing is, during the peak of the COVID-19, I was dealing with HRA consultation for Petronas, our oil and gas company, and also for DHL Logistics. These two are big companies in Malaysia where they operate very large scale with very large manpower. But during the outbreak, they have to do shutdown and what do you call some work. So to do that, to continue the work, they were required to do HSC studies. So they contracted me to do it. So I just went. I took a big risk, but no choice. The thing is, somebody have to do the job. If not, the project cannot go on. So you have about 1,500 to about 2,000 people working on sites. If you don't go in and do that work, then the oil and gas will just dry up. We cannot afford that. So I said, okay, I will go. So they collected, we had few teams of people going in, but SOPs were very, very strict. We have to get ourselves screened, you go on site, you have to get screened. They don't want to send us into the site unless we are free from COVID-19. So they have to make sure I got my vaccination. Now currently I'm working, even though I'm working, they are asking me whether I've taken my booster. So we all